Well, hello everybody. Welcome to SkyTour LiveStream for this evening, September 19th, 2020. It's 10 p.m. Do you know where your stars are? We are having a really good time here so far. We will be spending a lot of time with you tonight trying to get some more objects out for you to see, and you will enjoy them, I hope. Just have to get back to our scene here. Let me just see where I'm going here. Just getting organized. I had a huge issue I had to work out in the dome tonight. Actually, I've been in there for a couple hours, as I told Daryl, who's with us. Hello, Daryl.
Hello, Mark.
And Amanda, who's also with us. Hey, Amanda.
Hi, Mark. Hi, Daryl. Hey, Al. Hi, everyone in chat.
Our wonderful Amanda. You know, Daryl always says everything's better with Amanda. He's right. And I'll tell you this: when we look at what's going on KGRA, you have to look at a new player on the block, and that's Amanda Curran.
Oh no.
Yeah. Amanda Curran has been spending more time helping out with KGRA. And I told her years ago, and she knows this, and everybody knows this, she's a natural when it comes to this stuff. She knows radio far better than she even cares to admit, you know, and I really like that. You know, I like what she does. She's really good.
Thank you.
Yeah, no, you're really good, and I publicly state that. You know,
Thank you.
It'll only be a matter of time before she demands a raise with SkyTour Radio, and then decides, well, I'm out of here because I have my own show now, and maybe I'll have you as a guest on, Mark, someday. I mean, you know, I don't doubt that can happen.
I always threaten to try to get you to do an interview one day.
Well, that's fine. You know, I mean, you know, I got, you know, I said to unzip a sweatshirt, sorry, and I just whacked my mic. So yeah, I'm definitely game for many of the things you suggest. You know, we met under inauspicious circumstances years and years and years ago, and that has since turned into a wonderful relationship and friendship with you. So I'm very proud of, you know, how far you've come along, not only in astronomy, but just with your technical prowess with the radio stuff. You're really good.
Thank you.
Yeah.
And I hear rumors that SkyTour Radio on KGRA Sunday nights at 8 Eastern?
Yes.
It's 9 for me. I'm an hour ahead, so 8 Eastern, Sunday night.
She didn't forget, folks. She didn't forget.
We might be going to StreamYard eventually.
Yes.
So
right.
We might have some pictures of, you know, who knows what. I mean, there's so much we could be looking at and discussing.
And there's a lot of imagery to go with it, you know?
Yeah.
Yep.
That probably still won't be on camera, but that's okay. We can put your questions up on chat, so if you have comments and questions and...
Don't worry, folks. We'll get her on camera. Shh, don't tell her I said that. And it won't be
I'll just be distracted, because you guys know I keep an eye on chat, and I keep an eye out for your questions, so...
Yeah, but you know what? I think people, just like they would enjoy watching, like, if I was in the dome, they'd enjoy watching what's going on in the dome at the same time. You know, like when I bring up this, you know, they like seeing what's going on in the dome over here, you know. There's a telescope looking out of the dome right now. We're looking in Cepheus right now. This is the northern horizon area that we're looking at. That's the north up there toward that area. And I think it's kind of cool, you know. Those of you that are eagle eyes will also notice that the screen looks blacker and things look sharper and clearer. In the interim from the last stream, which was last night, I have since added a different computer, and it's actually the very computer that's going to be used with the very telescope it's on out in Arizona. So this is the Arizona computer, and Marianne Robb in chat will be happy to hear that, because she's been hearing all kinds of complaints from me about how this computer's not working right, this isn't going well, and oh no, what am I going to do? But I'm ironing it out. The technical issues I had tonight, I think, are okay. Once it's set, it's set. You don't have to really play with it. If you really mess it up, you can mess it up. But when you're 2,500 miles away, at least for the beginning, and running it out there, you know, you have to be really diligent about the order in which you start up and shut down. And so that's what I'm going to do. Now, what's that dot in the middle? Well, that dot actually is this object. Okay, this is a this is a nebula called the Iris, and we're going to be taking a few photographs of that tonight initially, and we'll have some fun with the Iris. The Iris is in that's Cepheus, I believe, but I have to go check. Okay, I think we're in Cepheus here. Yeah, look, there's Cepheus right there, and if I yeah, constellation boundaries is that what you see there, those red lines? Those are the boundaries of the constellations, and if we come back, you see them. And the dome cam probably should just be shut off when I'm not doing anything crazy, so...
Cepheus looks backwards.
Well, I think that what you're seeing is probably because of the rotation. See it? In other words,
Cepheus is north of Cygnus.
yes.
Usually the peak there, it's like a crooked house with a sharp roof on it. The sharp roof points the other way.
Yeah, there's just the neb right there.
The whole thing looks mirror image.
You think?
Yeah.
I wonder if that has to do with the telescope flop here. Let me go this way and see if it changes anything. The Pleiades are also up, by the way, as is the Triangulum galaxy. Yeah, that's I think that let's do it this way. I mean, I can't.
Maybe your time zone is way off. That looks like a morning sky almost.
This is what it is now, almost. I mean, the rotation is the thing I think that's throwing us off.
Well, that's what I meant. Yeah, it's rotated like it's almost like a morning sky.
Oh. Well, yeah, because when you get over the pole like this, look at when you're so close, you can rotate like crazy because your telescope's almost pointing at the North Pole when you're this close. Because the telescope's axis, one of them is pointing right at that North Star, which is right here. That's Polaris, right? So we could end up looking like we're rotating around the pole, and we could be at any rotation angle, you know?
Yeah, if you back out some, though, that shows Cepheus is in the northwest. It should be in the northeast right now, and it should be flopped over. Is the time clock right for Stellarium?
Yeah. I mean, it's set for... Actually, I wonder...
Maybe that's what was messing you up earlier tonight.
I did notice that my clock out there was causing a problem, and I'm looking here, and there's the time right there. Look what it says.
Mm-hmm.
It says 8:01. But what's the time zone? And Earth, yeah, see, it's Earth and a town nearby. So I think that the time is off. Yeah.
One day I'll know the sky well enough to be able to tell that it's off by hours or in reverse or whatever.
Yeah. Well, we're gonna figure that out. We'll be figuring this out. Let me.
That's cool.
Yeah. Again, it's something to do with the computer that I did set the time correctly on the computer, but in fact, the time out there says 10:16, so it's correct. Yeah. Well, let me try this. Yeah, I set the time to... I mean, I set the time on Stellarium to right now, and I don't get it. It must be, that it says 01:16:41, and let's find out what that time is. Time zone, New York. Well, that's not true. That's weird. Date and time. that is not.
Sorry, I didn't mean to throw a wrench in the works.
No,
Sorry,
that's correct. I'm glad you did what you did.
I noticed Cepheus looked off.
Yeah. Okay, well this now is the correct time for us, according to this. And so that looks, so there's the north, so now we'd be looking up. Sorry folks, we're ironing out things. So you're kind of behind the scenes with us watching. So there we are. We're still going to the right stuff, so that's kind of interesting. Okay, but the time is now correct.
See, and hopefully everyone out there is following what's going on. It's like looking at a picture, only it's a reverse image. Daryl is seeing a constellation that's supposed to be, what is it, in the northeast, but it's showing on the northwest? Is that what's happening?
Yeah, I think that was why it looked turned like it did. Now the roof is pointing down, Mark, instead of pointing to the right like it was earlier.
Well, again,
conventionally it would be pointing to the left right now.
See, because what'd you say? You think it should be pointing to the left?
That crooked house shape, yes, the peak of the roof should be pointing to the left.
Over here? The only way it can point to the left is if it's rotated this way. And Cassiopeia is certainly not low. Cassiopeia is really high in the sky. It's almost overhead. So let's add some lines. Okay. See, there's the zenith up there. And that is what we see. So I'm not sure, and if you look to the right of all this, okay, well then we have the Andromeda galaxy, and we have the triangulum galaxy, and double cluster, and Perseus. We have the right stuff. So I don't, and Cassiopeia is correct. So
Cygnus should be visible up there right now.
It is. It's right there. Okay.
I don't think Cygnus hasn't passed the zenith yet.
Actually, it has. 10 p.m. Eastern Time, remember? 10:19 Eastern Time. I was just it's actually, if we look to the south, okay, let's look at this, okay? It's very close. Watch. There's the west, okay? Here's the southwest. Here's the south, okay? Now we go up, and look. Now we have the Cygnus star cloud here. Cygnus has already passed the meridian and is heading down. And that's not untrue. That's what it looks like out there right now. So then if I point toward the north, okay, this is what we see. I mean, Stellarium, this isn't mirror image. Because we see Cassiopeia like this, yes? And then we go down from that star. Actually, watch. See, the bottom star there that we use to go there is Sagene. And then from Sagene, we can go to the double cluster. And we keep going, and we go to Algol. See that Sagene to Algol.
Carry on, Mark. I take back everything I said.
Does it make sense to you now?
Something is off by a couple of hours.
Okay. All right, but I know that the computer time on the computer that we're running is 22:21.
Still, let's not belabor the point. Carry on, please.
Okay, I just wanted to get to the bottom of it for you. All right. Well, anyway. Okay,
It was pointing the other way last night.
All right. Well, we'll investigate it because I'm not sure. We were earlier last night too, but I don't. The Big Dipper should be over here. There it is. So, yeah, I'm not sure, Daryl.
Carry on, please.
Okay, look, a meteor. Oh, I was in Stellarium. Okay, so, anyway, folks, what I have the camera on right now is a very little nebula that is called the Iris Nebula. And it's a really interesting location because it actually has both reflection nebula, that they're called reflection nebula, and then diffuse hydrogen gas that's being illuminated, not illuminated, but glowing, caused to glow by the very, very high ultraviolet content of the star that's in the middle here. And if we do, say, a 30-second shot at 12,800 here, and for those just joining, I just wanted to mention, okay, this is our telescope control cluster. Down here are the filters we're using. We're on what's called narrowband 2, and if I roll the filter wheel back, you'll see we're on narrowband 1, which is a very, very, we're using tiny slots through the spectrum. Narrowband 2 uses wider slots through the spectrum to give only specific things where these particular nebulae are located. And then we have 3 more filters beyond that, including one straight through opening to just look in white light, like what you'd see with your eye, looking at an eyepiece without any filters whatsoever. So we're going to use that. So I'm going to control the telescope. I'm going to bring this up by hitting the S key here. This is south. And go down a little bit. And I'm going to change the speed. I'm going to go into the telescope computer and make a change to the speed so it goes up at a little more reasonable rate. Do it like that. Okay. And now if I do this, we should go slower. Yeah, there we go. Okay, so now we're going to go do... we have to wait about 11 seconds for our auto-guiding system to grab hold of a star. And to do that, I care about that only here in the Connecticut Dome, because if you notice in the observatory there, that's actual dome we're in. And I'm getting rid of this dome. If anybody wants a dome, I'm going to have one for sale soon. And I'm going to turn this into a roll-off roof shed because that's going to eliminate the roof on the building. It just rolls right off. And when it rolls back on, I close up. And it's going to be an identical copy to what's out in Arizona that we're making in Arizona. Okay, so let's go back here. We're going to take this beautiful, hopefully 30-second shot at 12,800. This is the camera control cluster over here. So that's all, and this is a live view. Okay, and many times we'll be looking at the live view and you'll see something go zipping right through, and usually it's a satellite, but it could be something different. You just got to keep your eyes peeled. You never know what you're going to find, and the Iris Nebula is really pretty, and as far as the Iris goes, it's this beautiful gas cloud. It's about 1,300 light years away, and it's got a bright star in the middle of it that's causing it to illuminate and glow. And you'll notice when the image gets done, okay, actually it's done. There we go. Right, you'll notice that this actually has it has a strange it has a blue tint and there's a red tint to it. You see that? That blue and red tint is something specifically that I was mentioning. Okay, this little reddish tint right here, okay, that's an area where the hydrogen gas is being excited to glow by the high ultraviolet light coming from that star. And then you'll see these dark lanes in here. You see some dark lanes right there and here. Those dark lanes are actually dust in front of the nebula, and the nebula is behind it. And then this blue that you see, okay, right in through here, okay, let me see right here. Okay, you see this blue? Let me get my hand back in there. See the blue there? That blue area, that's actually scattered light off of dust inside this nebula. So this is a wonderful birthplace for stars. It's got scattered dust going on in there. We have a lot of dust in here. There's plenty of ultraviolet radiation, and there's going to be clumping of material over time, perhaps. And those individual clumps will self-gravitate and form tight-knit more clumps. And more stuff will pile on once it's seeded with a lot of stuff like this. And those could become star systems someday. All right. So we're looking at the possibility that we're seeing, worlds in creation here. And I just think that's really so cool, So I want to do one more shot, and we'll do a shot here for 1 minute at 12,800. And again, we're using that slightly wider narrow band slotted filter to bring in only the blue and the red from the nebula, and the dark dust. So that's going to be hopefully a very good, give us a very good image. And
what is this called?
this is called the Iris Nebula.
The Iris Nebula. It reminds me of something that should be found in like Orion.
Yeah, it does.
Like, you know how I say it's like, I always think of it as like an angel holding something? Like
Yeah.
that thing it's holding. It kind of gives me that impression, like, where you said the lanes were, kind of like, looks like it's going
Yeah.
like wispy off to the left. Maybe it's my bad eyesight, but...
You're talking about this right here? Like right here? This little stuff up here?
even up a little more, like
Or
at the
this?
top and bottom, it almost looks like wispy little feathers coming off the
Like
top
that
and
here?
bottom.
Yeah, that's true.
Yeah.
And then here, there's some more. Yep, that's very true. And that is something that's actually within the nebula. But remember, these are all in 3 dimensions, so who knows if that's not something coming toward us and behind us.
Yeah.
We don't know. I'm just gonna make an adjustment here.
But it has, like, do you know what I mean with the Orion Nebula? I don't know if it's I guess it's a nebula.
Yeah, it's the Orion Nebula.
Hopefully I'm thinking of the right one.
I think
It
you
has
are.
that kind of same wispy look to it at the top and bottom
Yep.
of one of the bright stars in it. I don't know if it's up, if we can look at it later, but remember this image. Keep this image for comparison.
You're talking
Maybe
about
I'm misremembering.
You're talking about the Orion Nebula?
I think so.
Yeah, the Orion Nebula is beautiful.
Yeah.
Yeah, it really is. I got just by the way, I haven't been ignoring you guys. Welcome. It's so nice to see you guys. I see Rachel's here, Don Walker, nice to see you. Tim F is here, and we have Gina Leone and Bobby Burgess, and of course Amanda is Dana Fan 1, naturally, and we have a number of other folks here. Terry Groff is dropped in. Nice to see you again, Terry. So I hope that you guys, and Tara, naturally. So if you guys have any requests, if it's up, we'll check it out. All right. And if you ask for Mars, don't worry, you're not alone, because Daryl and I and Amanda all want to see Mars again. We looked at it last night, and we're gonna check it out again. But I hope that you you'll stick around for some of that. But it's a lot of fun. What's that, Daryl?
I said, yay, Mars. I'm sorry, Amanda, you said something?
Oh, I was going to say, a while ago, I was toying with the idea of pitching a segment to you, Mark. I don't think Daryl really cared for my idea, but it would have just been a fun, little astrology section. So Mark's cringing already. No, depending on what planets are in what constellations, maybe we could just make up our own stuff. Like, if you're such and such sign and Venus is in your constellation, maybe you should go out on a date. Maybe you'll have good luck or something, And then people can get back to us the next time we stream and they'll say, hey, it worked, or you're full of it, which is probably the most likely answer. But,
I think that's...
Mars is in opposition right now. Don't watch your tongue. Don't lose your temper. Don't say anything you might regret. Mars, god of war, aggression. Be careful out there, Let's see if it works.
I find that to be an interesting topic, an interesting idea.
Oh, it would just be for fun, for entertainment, but people could play along, and people like hearing things about their signs, even if they don't buy it. They just...
Yeah, for sure.
Like when you get a calendar, don't you usually go to your birth month to see what your picture is? No? Just me?
I could.
Be honest, chat. Do you guys do that? You get a new calendar, you'll go to the month of your birth and try to get the picture? No? Okay, well, yeah, I'm back. You guys wanted me back, I'm back. This is what you wanted.
No, hey, look, I wouldn't have wanted you back, and neither would Daryl if you weren't a tremendous addition to SkyTour LiveStream. You know that.
Ah, you're hilarious.
It's true, though. Why would I say something that? Why would I say something false? I certainly.
Yes, then we have a 13th sign now. That's true, Terry. I would have to switch them all, but I like being a Gemini. I don't want to be a Taurus or a Cancer.
Okay.
Astrology joke.
Okay.
Okay, back to science.
Yeah. It's sort of sciencey. I'm trying to figure out. Oh, okay.
I've never been a big proponent of astrology. Of course, once upon a time, astrologers and astronomers were the same thing.
They were. Daryl's right.
Yeah.
He's talked about it before,
I know.
too.
I know one thing though. Not that it means anything, but this is personal. I have been in love 3 times in my life. Every time it was a Sagittarius, and every time it was love at first sight.
Wow.
Ooh. You probably haven't looked into what the characteristics of a Sagittarius are, but I wonder if these girls all possess that.
I have looked, but it's been so long I don't remember. I know we weren't supposed to get along.
Oh, is that true?
Well, according to astrology, we're not supposed to get along. Capricorns and Sagittarians, I guess, but maybe that's why all 3 failed.
Aww.
Oh. Well.
Anyway. Well, if that could be fun if we were to do that on the show.
Sure.
Amanda gets the astrologer's hat though, because I don't know anything about it.
I don't either.
Oh, I would just be making it up. So, I mean, let's get that out in the open right now. This is just for fun. I mean,
there you
I
go.
don't know anything about it either, but
well, it might be time to start learning.
Yeah.
Well, yeah. Maybe so. So here we go. This is the nebula now. You can actually see after a minute. The telescope's guiding well. You can see this beautiful blue area here, and there's red at the fringes. There's some red in here. Wow, this is got the makings of a really gorgeous photo someday. If I take a bunch of these and stack them, we could end up with a really nice image of the Iris Nebula. You know, that's nice. Yep. And let's see now. There's something else going on in here, isn't? Well, we got plenty of things to see, but I wanted to show you something else that might be in our line of sight. You know, I've never tried to take pictures of the Elephant's Trunk Nebula.
Oh no, that was the wizard we looked at last night.
Yeah, that's right here. We did that.
Yeah, elephant trunk's up in Cepheus too.
Yeah, that's right here. Oh, actually, we have the Heart Nebula. Right? Oh, we have the Heart.
We have the Heart and the Soul up in that
Right
area
there.
someplace.
I think they're right here.
Right next to each other.
Yeah, I'm just wondering. I'm wondering if I. Okay.
That's Cygnus right
What am
now.
I going on? That's Cygnus. I don't want to be there. I want to be. Is it down here?
Cepheus is a pretty neat constellation. There's
Yeah.
It's the king, of course. Cepheus is the husband of Cassiopeia, the queen.
Yeah.
It's actually there's a lot of big dust clouds up there, dark clouds in the galaxy, one of the spiral arms, and a lot of nebulae. There's the Heart.
Yeah, so we're gonna go there. You'll see the stars have just vanished over here, and the telescope works by finding a bright star. You'll see some zipping through the field, and you'll see one that gets locked on. And is that the one? That may be our lock-on star. Just have to give it a moment. There you see it up there, and once it finds it in its view, it's going to auto-center it, and then it's going to go from there to the nebula. And let's just see what happens. Okay. Okay, so it thinks we're here. We might be there. wonder if those two stars are those two stars. We'll find out. All right, so we have to give it a couple seconds here to obtain a guide star, and then once it has the guide star, we will be ready to go. All right, let's do a quick shot just to see if we are even close. Sometimes we're not. Again, I'm telling you, the telescope was acting up today, so I'm not sure. I have steered to some things without any problem, so we'll find out if it's going to continue its wonderful work or if it's going to fail. 25 seconds, 12:08 might be okay. Might see some, but we are on a filter segment, so I don't see it. Maybe it's there. The stars are beautiful no matter what, anyway. Alright, let me move my mug out of the way.
Looking for the Heart Nebula?
Yes.
Is this the same heart as the Heart and Soul Nebulas?
I believe it is. Let's go back to our quick shot here. There's the heart. And actually, the fish head is easier to...
Yeah, the fish head.
It's easier to see. So,
yeah.
let me see if...
Then there's the Soul Nebula just below it.
Below it, yeah. I'm going to take us up to the fish head, because the fish head shows better many times, and I just want to see if it's there. So, it could be that that part of the nebula is very faint. So let's try and do this. Okay, so we're coming up, and we're gonna go over. That's the wrong way. The other over. Okay, so I'm steering the telescope manually. Okay, so this is where the fish head is. Very cool. We're digging through things. We're gonna find stuff in the sky. All right, I believe that is where we wish to be. All right, so now let's do 25 seconds at an impossible value, 25,600. I could have just been too low on the settings. Amanda's a Taurus?
If you take precession of the equinoxes into account.
Yeah.
I am a Gemini.
But
So
she's a
you
Gemini.
That's okay. Where are we here?
What matters is that you believe.
Yeah.
You would look good in an astrologer's hat, Amanda.
Oh, why, thank you. Marianne wants to know if we can see the Running Man Nebula. Is that up and about?
And it's not until later, but it'll be way too late because Ryan's up around 4 in the morning. You know, at the point where it's high enough to see, and it won't be visible really well. Okay, this is clearly I'm not seeing it, so we're having yet another issue. Here we go. So what I'm going to do is actually, what I'm going to do is this. I'm going to go find a specific star and look at that specific star. Let's actually go to Seguin and go check out that. You'll see the stars zip away right now. Yeah, see, it thinks it's way over there. But let's see where it brings it into. Where it centers it. I might be able to fix this. believe it thinks that. Oh, wait a minute. Uh-oh. It's doing an auto center.
Is this what it was doing to you before?
No, this is what it should be doing. It should be auto centering Seguin. And we should see the telescope come back to us right now. It's the north, south, east, and west movement keys are blocked out. And now it's back. So this is Seguin. Now what we can do is drop us down to say, just to confirm, 12,800, do a 25-second shot of Seguin. And when we do that, when we look in Seguin here, we should see, now I see it shows the scope being off a little bit, but I want to make sure that we're where we need to be. First things first, let's get our image. I don't see this star. Oh, maybe that's this star, because we're flipped. Yeah, that's that star, because we're flipped. When I say flipped, you'll see what I mean. Because the telescope's vertical and over the back, so to speak, it rotates the imagery. So when we look at it, it's like this, see? But to make this look right, we just have to rotate it to the right. And now we have our two stars here that are bright. And let's bring up our beautiful planetarium system and move this over first. Zip in and move over. Okay, and now if we bring this up, okay, we can see that Seguin, well, that doesn't look right then.
Doodah.
Yeah. I have to go to something I absolutely know, and then we'll
Try Vega. Isn't that usually the default starting point?
Not usually, because I have to actually move the dome for that.
No.
But I know that. Well, you know what? Why don't we just go to? We can't do that because I gotta find it. I just gotta make sure it's all working. I don't want to close down. Not early. No way. Oh, I know. Let's go back to the iris. Where is the iris? Is it? It's up here. That's the wizard, and there's the iris. So there's the iris. So I'm going to go back to the iris, and I want to make sure that it's working. It could just be the illusion of the telescope flipping the image. Hello there, Ronald.
If you need a good finder star, Deneb is just west of overhead for your point of view.
Yeah. Okay, so let's see what the heck it's doing. Okay. Alright, that is the star that we would be lining up on. And that's this star right here, if it's doing it correctly. Which is Cablefield. Yeah, and then from there it's going to zip. You'll see it go away as soon as it centers it up right. Alright, momentarily it'll be there, and then the next moment, like a magic trick, it's gone. And you'll see it streak out. And then we go down to the iris from there. And there we go. And now you'll see as we move into the iris. And there's our star that we were looking at before. So it's working right. It's correct. So I have to figure out why. I have to figure out why it was doing what it was doing. But that's okay. As long as it's working, I'm happy with it. I'll just make sure. Give myself the 11 seconds. And then we'll do a quick shot here to make sure that's the iris as we suspect it is. There we go. Hello there, Adam Lorber. Nice to see you. And yes, we will look at Andromeda. Absolutely. Make sure you subscribe, Adam. We do a lot of really cool deep sky stuff.
But hit the bell for the notifications, because we can only do this when the sky is clear and Mark is free. So it's not like we can say every Friday at 10 we're going to go, because...
Yeah,
you
there
know,
it is. So it's there.
Everyone make sure you hit that bell to get
absolutely.
notifications when we go live.
Absolutely. Make sure you hit the bell. Okay, one thing I'm going to do here is I'm going to just make a slight modification to the view here. I'm going to...
Speaking of notifications, I've started getting email notifications again. I thought they quit doing that.
Are you sure that the notifications from the email were notifications about streams going live?
Yours did tonight. I know that. It did it last night too.
Okay.
Plus, somehow Windows 10 is giving me instant notifications now.
Ay. That's crazy. Adam, just so you know, you're listening to Daryl Mason, who's with us here, and you're listening to Amanda Curran, who is with us. And you can also listen to all three of us on Sunday nights from 8 to 10 p.m. Eastern Time on kgraradio.com, and you can listen to us on our all astronomy show called SkyTour Radio. It's all things SkyTour here. This is SkyTour LiveStream, SkyTour Radio on KGRA, and SkyTour LiveStream has this observatory here in Connecticut, and we will have a second observatory online at the end of October, I believe. And at the end of October, we're actually just a few days from now, I'm flying out there to build the second observatory. And we're not using a dome, we're using a roll-off roof. The roof's going to roll off, telescopes will be inside. Yay, they can look at everything in the sky. The roof will roll back on after we're done. And it's all automated. So we can run it from here. Where is here? I'm in Connecticut. Daryl's in Colorado, and Amanda's in Nova Scotia. So you see, we're in, well, kind of international, aren't we? We're sort of an international triumvirate of astronomy enthusiasts. So I have a feeling that you'll enjoy it here. You know, look at that nebula. That's a beautiful nebula. Yeah. So it looks like it's working, Daryl. And to those confused a little bit, this is a brand new system that I'm using right now to look at the sky. And so I don't mean telescope. The telescope's the same one, but this is a whole new computerized system that I implemented yesterday evening, I might say. And between then and now, I've been frantically trying to work out the bugs, because the computer system needs to get out there before I get out there in apparently 6 days, according to Marianne Robb. Marianne is helping greatly in the desert to figure out all the contractors and who has to come when, and she's a heck of a coordinator. I have to just say that I could never do this on my own. So with all of your support, and Daryl and Amanda's support, and of course Marianne Robb, we're doing fantastic, and we're doing really good. I also have to do a shout out to Tara, who's also in the chat, because Tara has also been helpful in getting SkyTour LiveStream out there. She's been offering to help. She's a crazy good UFO investigator, and I'm the Mutual UFO Network's chief photo and video analyst. So that, for what it's worth, means that I get to look at lots of really cool pictures and videos of people's UFOs. And I know you want to ask, where's the real ones? I haven't seen any yet. I'm also really hard on the data, so I need more proof. So okay, we got this. It's working. Now let's go and see what else we have here to look at. The fish heads should have shown up just fine, so I've imaged it a number of times. I might have to just go a little bit more in depth. We can check out the Wizard Nebula right now. So we're going to go from here to here, and to do that, we're going to have it find a nearby star. So there go the stars. Telescope is now zipping around. I should actually show you that. when we look at this guy here, we can actually bring up the telescope system, and you can actually watch the telescope move. Of course, it's pointing right out of the slot in the dome there. You can see that. It looks really nice. And this star, what is this star? Well, we look at our handy-dandy planetarium, and it will tell us what star we're actually looking at. That's what I kind of thought it was going to do. It's looking at the star Gamma Cephei. Is that Gamma Cephei? No, Zeta Cephei. Or Chi Cephei, sorry. And then once it centers it up, it's happy that it's centered, and boom, it takes it to the exact location of this nebula because it knows exactly where it is. Hi there, Brandy. Brandy's here tonight. Nice to see you. So good to see you here. I hope all is well with you, Brandy. I'm always interested in good news, so if you have good news, I'd love to hear it. And so let's go check out the Wizard Nebula now. Those two stars look familiar, Daryl, don't they? Good.
Sorry, I was on mute.
That's okay. I figured it out. No worries.
Maybe. I think so. I remember we looked at the Wizard Nebula last night.
Yeah, and those two stars were not in the nebula, but they were near it. And I thought they might have been in it, but I was wrong. Let's just do a 25-second photo to capture this Wizard Nebula. I think it's like, I think it might be right here. It might be right there in the middle. I've been fooled by this system before. You guys have no idea. This is going to be a remote system out in the middle of the Arizona desert. The sky is absolutely black. Well, and full of stars. And Milky Way. And maybe it's actually, I thought those two stars were part of it, or near it. Wondering if there's something. Yeah, there it is. There it is right there. Oh, I only did a 25-second shot. No wonder. Hang on. Okay, so now you can actually see a little better. There's the Wizard Nebula. There's a little dark lane there, dark lane there. But I really need to alter our settings. We're using narrowband 2. And that's fine. But we're going to go to 25,600. And we're going to go to, we'll try 30 seconds to begin with. Because it's right there like I thought. Now the odd thing is, one night when I thought that the nebula should be present and it simply wasn't, and I couldn't understand why, it turned out that the reason that it wasn't present was because of the fact that there was dew that had managed to settle on the telescope lens, the corrector plate at the end of the telescope. The opening of the telescope has a big glass plate, and that glass plate, there it is, look at that, right in the middle. Okay, now I'm going to explain what you're seeing here. Okay, this is the Wizard Nebula, and this is what's called the raw image. Okay, it's a file format that preserves all the data, all the good data, all the ugly data, everything. What I do is I take away the noise. Here's an instant processing for you to give you an idea. All right, and this is just an example. This very subtle nebulous detail in the Wizard Nebula. There's a beautiful star here that's actually causing a little reflection nebula here. And if I did a longer exposure or a higher ISO or sensitivity, we would end up seeing a tremendous wealth of detail. Or if I took, say, 20 of the same thing and then stacked them all on top of each other, and that's called, oddly enough, stacking, then we can actually see much more detail. And stacking really brings out a ton of detail beyond what you see here. And so, that said, the Wizard Nebula looks nice. And I'm actually more heartened to see that the telescope is doing what I thought it was doing to begin with, and I'm very pleased. So we're okay. We're okay for now. But
That would stack well.
Yeah.
The Wizard was a recent APOD photo.
Was it?
Yep, really cool.
Okay. Well, I'm going to go to a minute on this, and at 25,600, and we'll catch it. Now, if you notice, there is, when you're actually taking a photo like this, one of the things you need to understand, which some of you do, is that you need to guide the telescope. The telescope doesn't just follow the objects in the sky automatically. It's only roughly aligning with things. It has to actually be guided. So the magnifications we should use like a reticle and keep a guide star in one spot in the corner of the reticle, and just use a little hand control and make sure that star stays there for the entire duration of a, say, 5 or 10 minute exposure, and then do that 50 times. Yeah. You would be bored after the first 30 seconds, okay? So at the most, we take 1 minute pictures, and we're using cameras that go up to very, very high speed. And this will allow us to show you things. And then I process them later to show you the final result. Now, I've been talking to a guy who makes a special driver for our telescope's camera. And look at that. And he is... Look at all the stars, guys. Look at that. Just beautiful. And he's... his driver is making my camera function with a special program. Actually, this is the program that you will see when I show you here in a sec. This program here, which controls the telescope, actually has more to it. And we can actually take the photos in this program, display them in this program, and not use this one over here that we're using. It'd all be one program. And there's some things that work, some things that don't. So I'm waiting for certain aspects of it to come in, and then I'm going to possibly make the break into this program here to control everything we see. But I kind of like the different looks. It appeals to me, So I really like it. Now, we have a special guider that's sitting on top of the telescope. We've got another big giant telescope that's guiding the bigger telescope. Doing that guiding I was talking about, keeping the star at a certain spot. And the guider has to be tuned, and I tuned it earlier tonight. I set it to a particular set of settings each time, and that seems to work very well. But then the guider takes 11 seconds exactly to find a guide star. When I moved it just now, it needed to find another guide star. So that's why I delayed a little bit, and now I can take another picture. But I want to do a stack, and then if you're interested in seeing the final images, you can see the images on SkyTour LiveStream, our Facebook site. It's SkyTour LiveStream in Facebook, and you can go there and see all the images, or you can just come to my Facebook site, Mark D'Antonio, and you can see the images there as well, because I will put the images there, and then I will spread them to all the other sites that we share them with. All right, and they really, and the first one where I share them is SkyTour LiveStream. I have to put them in SkyTour LiveStream. I'm sorry, Mark D'Antonio first, because I have a lot of people that come looking for me, and I want them to find everything. So for me, it's a nexus to find everything else on my Facebook site. It's just the way it turned out. I don't necessarily need it that way. There we go. Look at that. Look at that. That particular one looks really pretty, Daryl. Yeah. Yeah, that's pretty. Let me process a little for you. There you go. So a little instant processing, you can see that we've got a lot going on there. Also in these images, be on the lookout for faint lines, because sometimes we'll catch satellites going through. Actually, it's kind of odd that we haven't seen one yet, Daryl. Normally we do.
This is true.
Yeah, normally we do. Normally we do. Now you may wonder, why is it that every so often you're going to see me move the telescope a little bit? Why do I do that? You know? What am I doing? Why am I doing that? Well, the reason is the camera sensor is a flat plane. It's a square sensor. It's the size of a 35 millimeter frame. It's a full frame sensor, it's called. And when you take a picture, there's a certain amount of noise generated by the acquisition process. And the higher this number here, the higher, oops, you can't see that number, sorry. The higher this number here, right there, that's the ISO, or the sensitivity of the sensor. The higher that number over there, the more we have to concern ourselves with noise on the image. So this number has got to be something that's reasonably small if we're gonna be able to image something right. And then this number at the top, the bulb setting, that means we can open it for as long as we want. And right now I have it set to 1 minute, but it can be anything we want. And then but the noise is there. And so I'll start this image here now, and if we go back to our other photo view here, okay, this looks pretty, right? But let me show you what happens when we zoom in. We zoom in, and look what you see. See all this grungy stuff? That's noise. This is signal. This is noise. Okay. Well, actually, this is noise. This is signal. I was actually showing you parts of the nebula, and some part of the nebula was actually signal too. It's just faint signal. So this is a beautiful nebula. We're going to take a few and then stack these. And Daryl, I know you're not on Facebook, so I will also send these to you as well, because I know you like to see them.
Thank you.
Look at a nebula.
You've got a lot of nebulosity. Yeah, you're pointing it out now.
Yeah,
got more going on there at the bottom of the image.
Yeah, it's just really pretty, and it's really a beautiful night, folks. And so when I was out in the dome, I was so frustrated that it wasn't working right that I was thinking, I'm not going to be able to show this to anybody tonight. And I really got quite sad. I really wanted to make sure that you guys could see this. I mean, this is just, it's just beautiful. It's just beautiful, you know.
I think you're going to be pleasantly surprised when you stack these.
Well, I've never stacked the wizard. You're absolutely right. I have never done the wizard. And the wizard is something that's new to me in terms of stacking. And what I was getting at before with all this noise, this noise, you want to get rid of that noise, and I can get rid of the noise. I can remove a lot of the noise. Hey, James Dugan. Okay, but to be honest, in order to get rid of the noise, you have to do some other things. You have to know how the camera's noise reacts when there's no signal like stars and nebula present. And those are what we call dark frames. Now, when we look at our telescope control system here, okay, this telescope control system has a filter wheel down here, and right now we're on narrowband 2, which is a reasonably good nebula enhancer. But if I go to position 4 in here, okay, that is a black disk that completely blocks the starlight from coming in. And I take a bunch of photos at the same length of time that this one was taken with. Those are called dark frames. And then when we have dark frames in place, then we can actually literally eliminate the noise. And by moving this around in between shots, in between shots like this, then we actually help to average out that noise while maintaining the signal. It's really quite nice.
Question?
Sure.
Does the camera sensor's performance or whatever sensitivity change over time? It would almost seem to me like you could take one dark frame and save it and use it on every shot.
In fact, what you do, and you probably know this, what you do is you take, say, 20 dark frames. And I would never do that with you guys here. I would do this later on after the stream's over. You take, say, 20 dark frames, and those 20 dark frames can be made into what's called a master dark frame. and that master dark frame is all what you would need to use with your subsequent photos. And that would help, definitely. So I have a library of master dark frames already. This is, I think, 12. No, what is this? This is 25,600. Okay, I've got a master dark frame for 10,000 and 20 seconds, and that's not the same, but it'll be something. Some of the noise will be removed by that. Really pretty though.
It's interesting. So you just shoot a series of dark frames at each ISO and save those, and those would serve in the future?
Yeah, only if the temperature is fairly constant. They're temperature dependent. When the camera's hot, you get different noise than when the camera's cold. So in the desert, however, and in Connecticut, where I am now, you could get away with seasonal variations of dark frames. So in other words, if you had an average temperature outside in like now, like say 45 Fahrenheit, if you have a bunch of dark frames you took at 45 Fahrenheit, let's say this ISO, this sensitivity, then you would be able to use that again for other frames.
Interesting.
Yeah. Hey there, Mauricio Mendez.
Excuse me just a moment, please.
Sure thing. Amanda, you out in the chat?
Pardon me?
Are you out in the chat, looking at the chat? Is that what's going on?
I am.
Yeah.
Maurizio dropped by. He said he's a huge fan and listens on Paranoid Radio app. He must be talking about SkyTour Radio on KGRA Radio.
Is he talking about the paranormal app?
Must be.
Paranoid, he said, because he wrote Paranoid. I think maybe they meant paranormal, but yeah, that's pretty cool. That's wonderful, Maurizio. Actually, we enjoy your listenership, man.
Yeah, I'm glad people are finding the crossover. People that find us here find KGRA Sunday nights and vice versa. I try to put it in Discord chat, but unfortunately some of our listeners even here are having a hard time with Discord. We are trying to get to StreamYard, and then we'll be available on Facebook and YouTube, as well as Periscope on Twitter. But I still don't know how to get in there myself, so that's a work in progress. One day in Twitch, but that's a work in progress. But hopefully you'll be able to find us on those platforms very, very soon.
Yeah, that'd be good.
Yeah, much easier for everyone. And
I look forward to being on that platform as well with you all, Amanda.
Yeah.
Yeah. Okay.
It's fun. It's so nice over there because I can put questions and comments on the screen. Yeah. And I keep clicking in the YouTube chat and I can't do anything with it because we're not in StreamYard. It's a nice feature to have, and I love when you guys request things to see in the sky. I have a request coming up whenever that might be an option.
Okay, well, we have one for Andromeda Galaxy. We have one for we have a lot for Mars. Mars will be next.
Oh, Mars for sure. Yeah,
not
it's in
next,
opposition. We got to do that.
Yeah, I'm taking advantage of the beautiful night though. We're going to look at some nebulae first and photograph them because you're literally watching now.
Mine's a nebula. My request is a nebula.
Oh, I know, but you're going to ask me for the cat's eye, aren't you?
Well, Rachel's been putting a lot of cats emojis in the chat, and I think she would get a kick out of this. And I really like the iris, and I was going to make a comment that cat's eye is even more brilliant, but the iris was beautiful. Those that didn't catch the beginning of the show, when we're done, it will be uploaded and left here on YouTube. Check out the beginning. You can even scroll back to the beginning and then catch up live, but the iris was gorgeous. Absolutely gorgeous. So stay tuned for the cat's eye nebula. I hope.
Well, let's find out where it is because I don't know if we'll be able to see it.
Andromeda is a beautiful selection, and Mars, of course. Mars is the feature of the night. Ooh. But if it's up, if you think we can find it and you think it's worth viewing, please do. We're watching chat, so questions, comments, or viewing requests, please put them in. Yeah,
the cat's eye is in a very unfavorable location at the moment. I apologize. I can't show you the cat's eye tonight.
Well, another reason for you all to subscribe and hit the bell.
Yeah.
You never know when we will see the Cat's Eye Nebula,
Yeah.
or we've caught satellites in images before.
We
We've
have.
caught, what was it, a meteor hit the moon? You caught that on a live stream?
Yeah, we actually saw the meteor
never
strike the
know.
moon. I mean, that's again, if you're looking up, sooner or later you're going to see something, and that's what we get. We're
Yeah.
always looking for things.
Keep looking up.
Yeah.
Except while you're driving.
That's what we say, right? I say, don't forget, keep looking up, and you say, except while you're
Except
driving.
while you're driving.
Yeah. I love it, you know. This is my full screen, by the way, that I show you a piece of. I'm showing you just the actual data, like here. But if you really wanted to see what else I'm looking at, I mean, this is the entire screen. Okay, I've got the thumbnails for all the previous shots, and then it's the directory structure on the drive out there in the dome. And it's just kind of ugly a little bit, and it's not really helpful, so I kind of just get rid of that, so you can see more detail. And you know, I got to tell you, you know, putting together SkyTour LiveStream was something I wasn't sure I wanted to do. To be honest, way in the beginning, I was not sure that I wanted to do this. Yes, I'm an astronomer. That's what I went to school for. That's what I make my living at, you know. And besides, I own a visual effects company, and we make models and so forth for some high-end clients in the Navy and so forth. But that's fun and enjoyable. But I'm really an astronomer, and I'm actually sort of remaking my life into that direction. That's what's with the 2 observatories. Why I'm doing 2 observatories, and we're gonna just keep working at that. We're looking for foundation support for SkyTour LiveStream. I'm looking to take a portable observatory around the country to college campuses, schools, businesses, and run evening programs for folks. You know, I've done that for years. I used to be the only astronomer at a science center, and I used to take a portable planetarium out, which is a step removed from an observatory. I like seeing the real thing, but the planetarium was good, and I would show people the night sky. But I got to tell you a little story. The planetarium was an inflatable planetarium. It's called Star Lab. Very well made, and it was a inflatable thing. You used to do it in a gymnasium, and everybody would come in through a tunnel. They'd crawl in through a tunnel. Targeted for kids, but adults liked it too. And I'd have this inflated planetarium, and I would end up showing them the sky with this planetarium projector was in the center. And well, you see, this thing happened, okay? The night before, I didn't get much sleep. And then when I ended up doing this planetarium show, I ended up not realizing that I was really tired from the previous night of not sleeping, because I'm an astronomer. I was up late. I was up till 2 or 3 in the morning, and I had to proceed to go to beautiful. I had to proceed to go to this place now and do this presentation for 30 people, and you're in the dark. And you're laying down on my back, looking up at a beautiful night sky generated by this planetarium projector. And I started rotating it to show the night sky go by. And I started to drift off. And I was talking about the night sky and everything. And then all of a sudden I drifted off. And I was sort of aware of like this faint words being said in this little dome theater that I was in. And aware of the fact that people were talking a little bit to each other, but and I hear somebody else saying, "Shh, I'm trying to listen. Shh, quiet." And I'm not talking, but the stars are still going by. And then I realized I'm hearing myself breathing like I'm sleeping. And I'm thinking to myself, "Oh, I'm asleep." And I was. I fell asleep. And I let an entire year go by. The entire sky went around one whole time, and then I woke up. And I said, just quick thinking, I didn't know what else to say. I said, I just wanted you to see what the night sky looks like without having to hear any words or anything else. I just want you to see it without any interruption. And I'm sitting there going, I am so dead. They're gonna like throw me out of here for falling asleep while trying to do a show for them. And they sent reviews in to the place I worked at the time, and they said, Mr. D'Antonio was careful not to fill all of the dead air with discussion. He allowed the people to absorb the sky on their own terms. It was like the craziest thing. I did not. I fell freaking asleep. But I took it. It was a good review. It was actually the best review I ever got. So what I did was I started being quieter when I was actually showing them a live planetarium show. I let them explore on their own, think about things. And that generated a lot of questions, a lot of questions that they generated. But SkyTour LiveStream is different. When people just show up here, they're showing up. They're not walking into a building and sitting in a chair. They're showing up, and don't know where. They just show up here, and they don't know exactly what's going on. So they'll see a nebula, and if they see this on the screen and they don't see me or they don't hear Daryl or Amanda, then they're gonna wonder what the heck they're looking at, and they'll go away. As long as they hear me talk and they see me on the screen, they know that we're talking about some of these things going on. So that's what this is all about, and I kind of like this approach. I hope you guys do too. I think that it's really a valuable way to approach the entire concept of astronomy. Is to be interactive like this. So again, I'm moving it in between shots too. We get a average of the noise.
I'm back.
Awesome, Daryl. Okay. I have to run and get a bottle of water. Is that okay? Because I emptied out my big giant glass. So do you let me...
Go for it.
I'll be right back. It's just behind me. I'll be right back.
Okay, bye. I don't know if he actually has a screen behind him now. Because I know when he's pointing things out, his hand is fading in and out. Like he's using a green screen, but he's usually in his office with a really cool sub background, so...
He's...
See? Like, why is he glitching in and out?
Yeah, it does that sometimes. I want to say he's in his workshop.
Yeah, but why can't we see his walls?
I don't know, ask him.
What are you using, Mark? Do you actually have, like, something behind you picking up this green screen?
No, it's a virtual green screen. It's not too effective because you can see it breaks up sometimes.
It's really glitchy.
Yeah.
But I thought you could only use that app if you actually had, like, a solid color behind you or something.
Yeah, I could put a green screen back there and maybe it'll be a little better. But what I like about this, this is cool. I mean, we're going to look at this in a little while, the Andromeda Galaxy there.
That's nice.
Yep. And let's see. We've seen a bunch of things. This is M76. This is M1. This is the Ring Nebula. This is Alberio, my favorite.
I was wondering if your cards were going to be the first 52 Messier objects.
No, actually they're not. The cards are going to be... and I designed the card deck and it's already on order. And the cards are actually going to be... and are designed to be the face card will have the Jack of Clubs, Jack of Spades, or whatever, but that's on the outside. On the inside, there's going to be on the face of it, there's going to be a picture. But instead of the typical pips like hearts or diamonds, you're going to see a photo taken in SkyTour LiveStream, and they're not the 50 Messier objects. They're actually our greatest hits. And I saved some of the best for the Ace of Spades and things like that, which you'll see. And so they're really cool. And, of course, my co-hosts get a free deck of these cards. I don't make them pay for them. And people that donate will get a deck of cards. We just have to come up with the regular... We have to come up with the right, methodology for how we're going to do that, So... It'll be nice, I think.
Amanda and I get free decks of cards.
Yes.
Yay.
When I get them in, you're going to get each one because of your work with me. I mean, you know, KGRA can't afford us to give us what we're worth right now. So if I can do something for us, I want to do it. So I'm going to give you these cards that have the objects on them. In the back of the cards, it says SkyTour LiveStream, shows a photo of the observatory with the red light and all the telescopes and everything. So it's going to be really a pretty deck of cards.
So the backs are all the same.
The backs are the same, but the faces are 52 different objects.
Right.
Yeah, that we took.
I misunderstood you sometime. I thought the backs and the fronts were different. I would think a guy could mark cards that way.
Yeah, that'd be a heck of a mark. And that's what's cool. Actually, hey, Dave Schmidt. I'm having one of the largest card playing card companies actually do them, and they allow you to do the design. So I'm actually expecting high quality. You know, and this is gonna be a poker deck. You know, the poker size cards initially.
Right. Everybody's doing that now. My last employer got into that. We worked with Shutterfly on a lot of stuff.
Okay.
Personalizing products like that, you know, calendars and such things.
Mm-hmm.
Of course, you can do calendars too.
That's right.
That might be nice.
Yeah, I would. I just haven't gotten around to it, but I'm planning on doing a calendar. But you know, here's me talking. You know, I look at what we're doing here, and I say to myself, man, we've got so many things that we can do. If I just wait a little longer, maybe what we can do is we can actually, get some really nice shots of this thing or this thing. I gotta wait a little longer into the season because I want that in the calendar. Next thing you know, you're waiting a whole year and you haven't done it yet because you're waiting for the better shots. And you know, this particular telescope is a much better telescope than the earlier one we had in there, and we're working on a plan to actually duplicate this telescope entirely. Because this one that we're using right now tonight is going out to Arizona with the telescope's computer that is now mated to it, and those two are going to be in the building out there, and we're going to have not two piers like I suggested earlier in a previous stream and otherwise and elsewhere in radio shows and stuff, but three. So we have our pier in there, permanent pier, with our telescope system on it, and it'll be in the most advantageous position for our deep sky stuff. And then diagonally across from us, in the other end of on the other side of the building, the other corner, is going to be another pier, and that pier looks like it's already rented by another streaming group, and they're going to be doing stuff with us. And that group is none other than P&K Space Imaging. I think you knew that, Daryl and Amanda. Maybe you didn't.
No, I didn't know that.
Okay. Keith and Paul are going to be putting an instrument in the other corner of our building out there, and I'll be getting a rent for that pier. And then there's a third pier. We're going to have an equilateral triangle, equal sides, right? We're going to have equilateral triangle, one pier, and another pier. That other pier is for the next SkyTour LiveStream telescope, which is going to be a rich field telescope to show us not just close-up views like this, but wide views of the unbelievable Milky Way from Arizona. So we're going to have one of the nicest capabilities, and I won't know which telescope to use. I'll be like, which one do I use? I want to use this one. No, wait, I want this one. Wait, I want a close-up. No, I want a wide field. It'll be so nice. And I'm just kind of crazy that way, I want to get it all and do it all. You know what the thing is? I love astronomy to death. I cannot tell you enough how much I enjoy this occupation, actually. Amanda knows this. Daryl knows this, and many of you know this. I've never wavered. I've always wanted to be an astronomer ever since I was 9 years old. And I never wavered. Okay, and it's just been rewarding, you know. And the way I get into astronomy was a whole nother story. All good from people that are amazing. But we ended up, you know, I've ended up being very, you know, well, I've ended up working on a number of programs and observatories. One program I worked at was, you see these stars here. Well, the universe is in 3D. Each of these stars is a different distance from us. And this star here, although it looks fainter, could actually be the closest one. It could just be smaller in diameter and have less what we call luminosity or intrinsic brightness. And the brightest one could actually be farthest away and be a supergiant. See, in other words, it could be a little thing up close or a big thing far away. And space is three-dimensional. So that 3D nature of space is what is really intriguing, because trying to figure all that out and figure out how these objects all relate to each other, how they actually end up, relating to us, is just an immense. It's immensely satisfying to go through and check it out and learn about it. And I love to learn about it. I never get tired of learning. Never. Okay, so let me just count the shots. I left this so you can see. Okay, you can see the files here. These are called raw files, ARWs. So we have 1, 2, 3, 4. And then we'll scroll over. And we have 5, 6, 7. Oh, I messed that up. I gotta go back and do it again. Sorry. 1, 2, 3, 1, 2, 3, 4. 4 done so far. 5, 6, 7. I'll explain what I'm doing in a second. 8, 9, 10. Okay, good. We got 10 minimum. That's a very good starting point. Good, we have 10. I'm happy with 10. In between are JPEGs. These are like little thumbnails, so I don't count those because we would never use those. You don't use JPEGs to do stacking or anything like that. So we're set. We got our Wizard Nebula Darrow, and we're going to stack that for everybody. So, and I'll send you, I'll send it to you as well, Amanda, so you can see it. But you'll probably see it on the website, on the Facebook page.
Super. Looking forward to it.
Yeah. Now, let's see. We had a request for the Andromeda Galaxy before, and I'm going to take us to the Andromeda Galaxy. That's 110, actually. But we'll go to the Andromeda Galaxy. And there's also another galaxy right next to it, and that's called Messier 32. And these are companion galaxies to the Andromeda Galaxy. So we have Messier 110, Messier 32. This one is Messier 31. Messier was a man who lived in the 1700s, Charles Messier. And he came up with a catalog of objects, as Daryl has told you before, and even Amanda has told you before, that are objects to be avoided if you're looking for comets. Hey, pretty cool, okay? If you're looking for comets, don't go to the Messier objects, okay? He says, yet he compiled a catalog of some of the most amazing objects. And Amanda wants this thing called the Messier Marathon, and I agreed. Oh, gosh. There's a particular month of the year where it's possible for you to go see every single Messier object in one night, and it's called the Messier Marathon.
It's 110 objects, folks.
Right,
110.
And I bring that up because look at the last object here. This is it right here. Messier 110 in the Andromeda Galaxy. A fitting end to a Messier Marathon is to look at that.
Ronald wants to know how far apart the companion galaxies are. Good question.
I'd have to. Well, let's see. First of all, this one here is 2.68 million light years from us. The Messier 32 is 2.48 million years. It's a little million light years. It's a little bit closer to us. And the Andromeda galaxy itself is 2.5 million light years away from us. So M110 is a little further than the Messier galaxy. The Messier galaxy is the next closest, and then the Messier 32 is the closest still of the three. So that's farther, closer, closest. Okay, kind of cool.
You could probably say those are analogous to the Magellanic Clouds down in Earth's southern sky.
Yep.
They're within a couple 100,000 years of each other.
Yep.
On the order of.
Yeah, light years. Yeah. Absolutely true. So that makes sense. And I want to just say something to everybody too. You know, I know about the astronomical concepts and so forth, but as an astronomer, I never really learned the sky as well as Daryl Mason, who's here. Daryl knows the sky like the back of his hand, and I dare say he's more knowledgeable about the sky itself in terms of where to look, what it's doing, what's this, what's that, than I am. But you'll say, but you're an astronomer. And Daryl says he's an amateur astronomer. What defines an amateur astronomer? What defines a professional astronomer? You know, I was paid to do it. That's what makes a difference. You know, well, Daryl was paid to do astronomy too. Just from his point of view, he did presentations for people. I did presentations for people. I worked on astronomy programs in observatories. But that doesn't mean that he's any less of a professional, for instance, than I am. I think we're professional astronomers, but just from two different points of view. And together, maybe Daryl, maybe we make a whole astronomer. I'm not sure.
Oh, humbug.
Nah, humbug is reserved for people at Christmas who hate Christmas.
I never got paid. I got a few free camping spots. That's about it.
That's cool.
I did it for the love of it. And when it got to be too much like work, I quit doing it.
Yeah.
Doing public programs anyway.
Yeah, I do what I do because of the fact that I think people really... it's just so exciting to see the look on people's faces. Daryl, you have a story that I think you should tell when I go move the dome, if I have to, for the Andromeda Galaxy. And it's about that little person, that girl, I think it was.
Yes.
You remember that?
Uh-huh.
I think that'd be a great story to tell folks. I'm going to go to the Andromeda Galaxy, but first I have to go make sure the dome's in place. So you want to tell that story while I go?
Yeah, I can do that.
Okay. I'll be right back.
Years ago, I was doing my annual summer camping trip down in the San Juan Mountains here in southwest Colorado. It's probably the prettiest place in the whole state. Spectacular mountains down there. And I was staying at a state park, and I had the deal was they'd give me a free camping spot for a week, and I would do a presentation, a lecture, and host a star party, 2 star parties, one the night of the lecture and a bigger one up on top of the hill. And Saturn was prime time that year, and I had 3 telescopes up and running, and I was back and forth a lot trying to manage all 3 telescopes. And the crowd, we had better than 100 people on the hilltop that night. And there was this one young girl. She stood in line at one of the telescopes and waited her turn, and she got up to it, and the telescope was pointing at Saturn. And this was my apo refractor, gave a very nice high quality view. And she was just totally overcome. And she just looked and looked and looked, and finally the people behind her were waiting their turn, and they wanted to look, so she went to the back of the line. And she must have gone to the back of that line like 50 people at least half a dozen times just to keep going back and looking at Saturn. And she was just totally overcome. And that's one of those nights where, I saw someone really getting it, I guess. And enjoying it, and that just made my night.
I like that story.
Me too. I've heard it before, and I just think that's a very touching story. I set the telescope toward the Andromeda Galaxy so you see stars streaking through.
And Mark, even when you were saying, like, you never wavered in wanting to be an astronomer all your life, and that love of it never went away, everyone in chat was commenting how obvious it was when you do these streams that they can actually see and feel it, and your excitement is contagious.
Oh, that's fantastic.
They see, you've been doing it your whole life since you were, in the single digits when you were a young boy, and it's still like you're seeing it for the very first time. And that's incredible, so
yeah, it's
we
familiar.
appreciate it. That's why people keep coming back.
I love it, and you've and Amanda, you're very good about trying to keep a pulse on what people think out there. Sometimes I miss some of the comments because you can imagine I'm doing like 6 things at once, so I don't get a chance to look. However, I do see that we have other people here that have joined, that are here now. And Governor joined us again. Adam Lorber came in, and I think I said hi to Bonnie on a Hottest 77. If I hadn't, I'm sorry. And of course, Ronald, you're always here. We appreciate you. Yeah.
And keep in mind, a lot of people that live in the city or, God forbid, polluted areas or just really, brightly lit areas.
Yeah.
Some people would love to see this and they just can't, or they would have to drive like an hour out into the middle of nowhere to see something, So, and
true.
I constantly have bad weather. Anytime there's a meteor shower, anytime there is a lunar eclipse, anytime there's anything we're seeing in the sky, it's either raining or snowing. So we need channels like this, for sure.
So many people have never seen what the night sky really looks like.
Yeah.
It's
Have never
true.
been under a truly dark sky.
That's true.
And I think that's sad, because you might have heard stories of people who live in big cities, the lights go out, they have a power failure, and they freak out when they see the night sky as it really is and should be for the first time.
Yeah.
And they're shocked and they're frightened.
Yeah.
And I think that's just a sad comment on modern society.
Sure. I think, like here now, there's the Andromeda Galaxy. You can actually, this is one edge of it. There's the nucleus up there, and then we're seeing a dark lane here and comes down. This is only a 25-second shot. I'm about to take a shot that's a minute long. You can see a complex of stars over here, and they'll be more evident when I take this other shot. But, so the telescope can see this much of the Andromeda Galaxy, okay? The other half sticks out further up there, and we'll check it out. I want to actually see if do I want to go this way? Is that 110, you think? And it's 32 down below, I think, yeah? I'll have to see. Look at these stars out here.
I would guess so, yes.
Look at these stars out here. You can see this cluster of stars. In the disk of the galaxies, and the purple color is just because of the filter we're using. But this is really yellowish, and the disk is more blue. And these are very hot young blue stars out here in an association of stars. Many times we call those OB associations. And Amanda, I think you know why we call it an OB association, correct?
Because it's in between the top 2 biggest, brightest, bluest stars, hottest stars.
Yeah, almost exactly correct. Yeah, and then we classify our stars.
Top end of the spectral class scale.
Yeah, which you can share with people if you like. I know that you're very good at it, and you have absorbed that. And so, rather than have me dribble on about it, I want you to dribble on about it.
My famous catchphrase. It's because of a mnemonic. Oh, be a fine guy, kiss me, or oh, be a fine girl, kiss me, whatever your preference.
That's how you remember it.
And the O stars are the biggest and bluest and hottest. And then they get smaller and cooler, relatively speaking, and more red. So you can have a pretty good idea of what kind of star you're looking at just based on those clues. Except the
Exactly
heat.
right.
You can't see the heat.
Exactly right. Yeah,
Except
and
colorization.
what she's it's OBAFGKM, and our sun is a G type star, and within each of those letters we have G0, G1, G2, all the way to G9. Okay, so there's 10 designations within. And then after that, that's called the spectral class. We also have something called a luminosity class, because you can have stars of different brightnesses, intrinsic brightnesses, but they're differentiated by what they're actually doing in their cores. Inside their cores, they could be building new elements for the periodic table through fusion. Like in our sun, we're making helium out of hydrogen gas. The process is somewhat convoluted. I won't go through, how deuterium is combined with hydrogen, blah blah blah, to make two isotopes of helium. But that's not a problem. The issue is that these larger stars are running out of their hydrogen, and when they stop doing the hydrogen to helium thing, okay, they go away from the normal brightness. They go much brighter, and they get bigger, and bigger corresponds to brighter because of the actual size they're taking up. The larger the diameter, the more brighter they are. All right, so that's what we see. And these stars are, when they reach outside our normal pattern of hydrogen into helium, now they're burning and fusing helium into carbon into nitrogen and oxygen and neon and fluorine and so forth, all the way up to iron, which is number 26 in the periodic table. Beyond that, there's other little processes that go on in stars like our sun and very, very high mass stars, where the stars can make higher elements in the periodic table through a number of processes. For those that really want to look it up and are interested, you can look up the S process or slow process. It's called neutron capture. That's how stars like our sun can make, over a long period of time, additional elements beyond iron in the periodic table. And it has to do with, the protons in a nucleus of an atom and neutrons, which are, chargeless objects which just have mass. Well, the neutrons can be turned into protons. So if you have one proton in a hydrogen atom, as you normally do, and one neutron, okay, then the electron, okay? Well, in the stars, it's all plasma, meaning that the protons and the electrons are separated by this massive energy that they're being hit with from inside the star's core. And the electrons go away, and all you have are the protons running around and the electrons running around. That's plasma. So when the plasma in a hydrogen atom, when that proton when that's joined by a neutron, all right, and you have this proton and this neutron hooked up with each other, that becomes something called deuterium. All right, it's an isotope of hydrogen. It's not a new element, but it's a variation of hydrogen. Okay, and I can't call it a different flavor of hydrogen, because flavor actually does have a specific meaning in this terminology. So it's a variation of a hydrogen atom called deuterium. It's an isotope, right? And you can change that neutron in a hydrogen atom, or in any atom. That neutron can be changed into another proton. And what defines where you are in the periodic table is that particular number of protons you have in the nucleus of the atom. Okay? Helium has 2 protons. It's in position 2. Okay? And then you have lithium with 3. All right? Beryllium. And it goes on and on and on. Carbon, nitrogen, oxygen, fluorine. So it goes on and on and on. Krypton, and all the way up the periodic table to 26, which is iron, and then other processes fill in the rest of the table, including supernovas, which, if we're lucky, we'll get to see Betelgeuse go supernova someday. Oh, I really want to see that. Won't that be cool, Daryl? He's on mute.
Yes. I have very mixed feelings about that.
You want to see Betelgeuse
it
stay?
would be spectacular to see, but I would miss Betelgeuse when it's gone.
But it will be replaced by a new nebula forming that you'll see forming every single year. You'll see new changes in the sky.
This is true.
And that is something that will be somewhat spectacular. Okay, so this is the nucleus of the Andromeda Galaxy. It goes all the way out here and all the way down here, and then the same on the other side. This is not the full extent. It goes way beyond this and way beyond that. Okay, so let's just take another photo. And this time, just to give you an idea, we're going to crank up. We're going to be at 25,600, but we're going to go for 1 minute. Ooh, baby. 1 minute. Ready? Here we go. Now this 1 minute of time, this was only 25 seconds right here. And you can see these stars and this hot association of stars out here. You can see the dark lane here of dust in this Andromeda Galaxy. This is not a void, okay? This is actually a location where there's dust that's obscuring the galaxy behind it. That's how you view these things, okay, in many cases. So now, when we're done with the 1 minute, you're going to notice a very different view here. It's going to have a much more pronounced and beautiful look. You'll see this association much better. I'll zoom in. Okay, so when we actually look at, let me actually do the following as well. I'm going to take this guy and just move it over a little bit. Wow, look at that, huh? Now, is that a picture or what? There is the nucleus of the galaxy right here. And look at that dark lane. You can literally see it curling around the other side of the galaxy there. This elliptical galaxy, one of the companion galaxies, is here. And we're actually, we have to actually rotate this now to actually get a better view. So here you go. Check out how blue this association is over here. These are hot young stars. They're giving off mostly ultraviolet radiation along with the blue color that they have. Look at the convolutions and clarity. Watch this as we zoom in. Check out this clarity in this galaxy. Look at this. Wow. That is just beautiful. It's really a stunning night, Daryl and Amanda.
We have a few questions coming in.
Sure.
I think Daryl handled one because I wasn't sure what Ronald meant. He wanted to know the arc space something takes up. I didn't know if he meant Betelgeuse or is that M31? No. I don't know.
This is M31 here we're looking at.
Yeah, see, I don't know if he's talking about that or if he's talking about Betelgeuse or what. So, but Daryl answered him.
Yeah, I assume that's what he meant.
Yeah. And Adam said Betelgeuse could have went supernova already, but it would just take a while for us to see the light stop, right?
Very good, Adam. That's exactly right.
How long do we have? Like, it's 8 minutes for the sun. What is it for Betelgeuse?
About 750 years. If it happens yesterday, we won't know for 750 years about.
Wow.
Yeah. Yeah.
You know, I keep seeing estimates for Betelgeuse's distance change.
Yeah. So do I.
They had a diagram of Orion and its star and nebula distances on APOD yesterday, I think, last night. And they said now that I'd had to go back to look again, but I think they said they think Betelgeuse is like 500 light years away.
I was always, growing up in astronomy, the distance to Betelgeuse was published as 450 light years. Only recently did they start saying it's over 750 or 700. I've seen estimates up to 800. I've seen estimates to 400. If they're saying 550, you know what? Maybe so. I mean, it's really hard to gauge the distance to a star like that. We can't do like an ordinary parallax. We have to use other methods. And sometimes if a star is in a binary system, it's much easier to figure out, and sometimes we can't. It's just there's many different ways to skin the cat.
Okay, I'm sorry. I went and looked. I misspoke somewhat. 498, they said.
Okay,
About 500.
that's fair. Yeah, I've always been growing up. It was always 450, but it's hard to tell the distance sometimes for some stars. Betelgeuse is a very odd star. It has a distended envelope around it of dust and gas because it's shedding material. And this could be, we know it's the precursor most likely to a supernova. Because Betelgeuse is, 20 or 30 times greater than the sun in mass, isn't it? So it's fairly hefty. And when it goes, it's going to go. And I can't wait to see it. So if it happened, let's say it's 500 light years away for real. If it happened 499 years, 11 months, 20 days ago, then we would see it in just a few days. So that light train has that information in it coming to us from Betelgeuse. When will that light train reach us? It's just also really cool. It's just, so really cool. And then we, of course, have the galaxy like this. I'm going to take us to the other end of the galaxy while I'm here. Let me just make sure I go to the right side of the galaxy here.
Okay, Mark.
Yes, ma'am.
We have a question coming in. I'm not sure what exactly the question is. Can you talk on element 115, please?
Moscovium?
Sure.
That's Moscovium, right? Element 115.
People are calling it something else, but...
Oh, well,
okay, what's your
Unimpendium.
opinion on Bob Lazar? I guess Marianne's getting messages from Alejandro, and he's asking about this element, and if it's you being able to fuel UFOs or something. I'm not sure where it came from. I thought, when Betelgeuse goes supernova, maybe it's going to expel this element. Is that the theory? I'm lost, so can you just talk about Bob Lazar and element 115?
Well, first of all, element 115, I think it used to be called unimpendium. And
yes, that's what David calls it.
Okay, that's actually been renamed. Those were temporary names. And it was named Moscovium, synthesized actually by Russians for the first time. And then Bob Lazar claimed there was an element 115, and we'd like to believe, all of us in the UFO field, that maybe element 115 was something that he was aware of that nobody else was, and now suddenly we know about element 115. And that may still be true. I'm not going to take that away. And when Amanda's talking about Alejandro, we're talking about Alejandro Rojas, who is, of course, he was with Open Minds for many years. He's the voice of reason and amazing journalist who lets everybody know all about the latest UFO cases. And I count him as a good friend. And he is level-headed, and so when he asks a question or wants to know something, I endeavor to give him an answer that he can use and make sense with. So,
I think he's watching on his big screen right now. So, hi,
he is?
Alejandro.
Oh, well, that's interesting. So let me do this. Hey, Alejandro. Yeah, that was kind of scary. I agree. So yeah, I think that when you look at element 115, the question of whether it can do what Bob Lazar says or not is still up in the air. But what do I think about Bob Lazar? I have to admit that Bob Lazar is in possession of an intriguing story. There's no doubt about it. It's intriguing. He claims to have worked on flying saucers at Area 51. He says things that some of which can be verified, but many things can't. And he claims that the government has stolen some of his, I won't say, identities, or not identities, but records of his involvement. He said he went to certain schools, but they couldn't find a record at those schools that he attended those schools. So, is he telling an untruth? It's possible. Is he telling the truth? It's also possible. I don't have a judgment on him. I think that of all things, he does have a very interesting story. And it would be arrogant of me to say that he's lying or he's telling the truth. I don't know either of those things. So I can only say what I feel, and I think that he's worth further investigation in his whole case. I really do. You know what I mean?
What about the isotope part?
What about the isotope part? I mean,
I don't know. What do you think about the isotope part? That's coming from Alejandro. I don't know.
Yeah, Marianne said that Alejandro specified it was a certain isotope of element 115 that was being used as a fuel or a power source for the UFOs.
Yeah.
And I assume they mean a stable, unknown isotope, since, as also mentioned, 115 has a very short half-life.
Yes. That's the other problem with many of these elements, is that they do have these short half-lives. And unfortunately, how would you use something like that? Do they use the power of its decay? Now, when elements naturally drop to another element as an isotope, what I mean by that is there's neutrons inside a regular atom. That makes it an isotope. Okay, atoms, when they're just atoms without anything going on, they're just straight normal atoms. They have protons and they have electrons. Okay, they don't have neutrons normally. You add a neutron, and now it's that different variation I talked about, which is the isotope. So various isotopes of atoms will make will have different lives, so to speak. Meaning that if you have an isotope of a particular type of carbon atom, for instance, it lasts a certain number of seconds. Now, how many? Maybe 10 to the minus 20 seconds. I mean, really a small amount of time. It's just a fraction of time in some cases, and other times it lasts for a little longer. And there's certain isotopes that they decay so quickly that you don't get a certain element out of it. But if you have lots and lots of these isotopes being made, there's a chance that some of them will be converted to this other element. And we play that game too in stellar astronomy as well. That's the best way to say it. And then if you look at these isotopes, when they decay, what is decay? Decay is where they spontaneously break down into other things. Now that happens all the time. And there's certain elements that come together briefly, and then this part decays into something else. Many times it'll decay into a positron or gamma ray or another type of particle, and then go back to being an electron, per se, or whatever. Well, anyway, if it happens to stick around long enough, maybe it can be utilized before it goes through this decay process. And there's a number of kinds of decay. Okay, we have beta decay. All right, and beta decay is the one that is the most important one within stars, in my view, because this is where stars like the sun can make other elements in the periodic table from, and via this method. And that's a spontaneous decay. And that's actually, in a turbulent environment like inside a star, it makes a whole lot of sense that things can get, rummaged around so much that they change very rapidly. And we see that inside these stars. As far as element 115, I really don't have a solid opinion of how we might use element 115, to be clear.
I suppose if one could deduce the properties of this particular isotope of element 115, it might be like the different isotopes of uranium, for instance, that the different isotopes have markedly different behaviors.
Yeah, that could be very true, yep. I'm going to
some can be used for atomic power or atomic weapons, and some can't.
Yeah. Okay, I headed to the other side of the Andromeda Galaxy to show you what it looks like at the same photo exposure length and sensitivity coming right up. Here we go. Okay, so this is it, and this is it. So, waiting for my telescope to give me a clean bill of health to say we're ready, and then we're gonna just go, because in 11 seconds we have our guide star. Yes, Adam, we're gonna look at Mars here in just a few minutes. I just want to show everybody the Andromeda Galaxy. Andromeda was by request, and then we'll be heading over to Mars to check it out. Then we'll probably do some more nebulas. Hey TK, yeah, that's actually somewhat true. There is that possibility, you know, that Lazar is, you know, kind of undid himself with this element 115 stuff. But again, it does remain to be seen, and we can't just outright dismiss it. Yeah, actually, Amanda did ask. Yeah, that's fair,
I'm
Amanda.
just kidding.
No,
Kidding.
no, you weren't. You meant it.
Get out of here.
Here we go. Here's the other side of the Andromeda Galaxy now. We're at the other side. And at this side, look what we see here. This is really pretty, because at this end, okay, we have this beautiful band of stars right here. Look at that. This beautiful band of stars right here. These are hot blue stars in one of the spiral arms. That's where the new stars are being made, guys, in these spiral arms of the galaxies. Okay? And these dark clouds here, these nebulae, this dark stuff is dust. Gas, if it's gas, it's transparent. You don't have dark gas that you can't see through. I mean, this is a collection of molecules, probably giant molecular clouds, like we have here. We have giant molecular clouds in Orion and in other places. And in Orion, for instance, we actually have the UUMC, you know, the Orion molecular cloud. You know, it's really neat. Hey, Keisha Fowler. You know,
May I say,
you may.
when we see those dark lanes in Andromeda, those are the very same sort of thing as when we see the Great Rift in our Milky Way.
Yeah, I have the. I usually have an all sky camera too, guys, and it's offline right now because I don't have it attached to the new computer yet. It works beautifully and it will continue, but I don't have it attached right now. But what Daryl's saying is exactly true as usual. And, you know, we look at these beautiful dark lanes. Look at how subtle the detail is in here. Look at that detail. Isn't that beautiful? You know, we also have that same kind of detail right here. Look at this. This is a beautiful little area right here. You know, I mean, this is just a beautiful swath of dark nebula, dark dust in this galaxy. Oh, man. To fly through this galaxy. One of the cloudy night streams I like to do is I like to take us for a trip in 3D around the entire universe, or part of the universe. And if we leave our galaxy behind, you actually can leave the disk of the galaxy behind and see it down below. And we look out and we see what look like more stars. Billions of them. Billions of other stars out there. But wait, stars are only in galaxies. So what are we looking at? We're actually looking at many more galaxies. Maybe up to 2 trillion of them beyond our own. And, you know, when you think that you might have anywhere between tens of millions to several billion other Earth-like planets alone, in our galaxy alone, and then there's other galaxies like this, which might have 2 trillion stars, you know, like the Andromeda Galaxy, or over 1 trillion stars, actually, then you're talking about a possibility that there might be some intelligence looking back at us right here from this galaxy while we're looking at it. Can you imagine that? Think that through. intelligent life out here in this other galactic location, looking at us and wondering whether there's intelligent life here, in the same way that we're wondering about life here. That's cool. That's really cool. I actually love this. You know, that's kind of funny because it looks like the light from the center of the galaxy is on my face. You know, I'm being illuminated by the galaxy. It's so bright. You know. So that said, that's the other side. I really enjoy that. So another star cloud here. You can see that right there. The Andromeda Galaxy is also similar to ours. Will have nebulae in it as well, and beautiful regions where stars are forming. We call those H2 regions, as in H Roman numeral 2, and H of course stands for hydrogen, and the Roman numeral 2 stands for singly ionized hydrogen. And I've said this before, you wonder why it's called H2 and not H1. Well, if it's H1, doesn't that mean singly ionized? Well, no. H1, Roman numeral 1, is the base state of an atom. So an atom without anything going on, without having had an electron bounced out by other energy, which is the ionization part, is in the base state, or H1 state, or the 1 state, the Roman numeral 1 state. When it's singly ionized, it's Roman numeral 2. Doubly ionized, Roman numeral 3. We love to confuse you. We like to throw these terms out at you. But hey, you know what? That's what we're here for, is to help explain them to you. So there's the Andromeda Galaxy, and it's really pretty. And this was 1 minute. I'm going to try something just for fun. I'm going to go in now and change our settings. This was 1 minute, and I had 2 seconds there. Let's go to a 2-minute shot, just for fun. I'm sure Daryl has another story he could tell everybody, you know, while we're waiting for 2 minutes to go by.
Give me a little context.
Anything is good. I'm, you know, if you have anything, you can say it, but otherwise, no problem. I was just messing with you.
Oh, I remember that same night the girl was so entranced by Saturn at the telescope, she kept going back to it. We had a bear on the loose up on the top of the hill.
Really?
And everybody freaked out, and must have scared the bear away.
I imagine so.
I mean, there was quite an uproar going on up on the mountaintop.
Yeah,
the bear was just making the rounds, hitting trash cans and stuff. And
yeah, they're very timid.
Usually.
Yeah, if they have cubs, then they can get defensive, but usually they'd rather run away.
Mm-hmm.
Hey there, Trevor Bateman. How you doing? Make sure you subscribe, man. Hit the bell.
He retracted his hello.
He did?
He did.
Why? He didn't want to say hello? Oh, Trevor, you can say hello. It's fine.
He said he liked stars, but maybe he got shy. You're in amongst the right crowd if you like stars.
Yeah, nothing to be shy about here, Trevor, if that's what it was.
We got stars here.
We do. Lots of stars.
Sorts of stars.
Yeah, look at.
We have O stars and M stars and star clusters.
Yeah.
Ah, he's back. Hi, Trevor.
Hey, there he is. That's all right, Trevor. You can be shy. It doesn't matter. You know, we all stepped out of our comfort zone at one point or another. You know, I've done it. You've all done it. Just imagine, you know, I mean, I get up in front of, you know, sometimes upwards of almost 1,000 people and talk about stuff, and, you know, it's not the easiest thing to do. But I do it because I know that the end result is that people will really enjoy it. Wow, look at that. Whew. Wow. And then you're going to get used to this with me. I will sit here and go, wow. This is a 2-minute shot, folks. Look at that, Daryl.
Uh-huh.
Wow.
Scope's tracking well tonight.
It is. And I'm going to, I think I'm going to go back to the other end and take another 2-minute shot with that other OB association that of the stars at the opposite end. I think that'd be really cool. Phew, man, that is just amazing. First things first, I'll go into a video mode where I can actually pump up the ISO, see the galaxy, and now I can take us to the other part I want to go to directly. Here we go. So now we're gonna, let me actually do it for you this way. So now we'll go down. Okay. And over a little bit. Or head over to the west. There's the other. Okay, there we go. Alright. And maybe a little more. See, what you can see when you look at other galaxies is really impressive. We can actually see, and I don't know if we'll see them tonight, but we can actually see globular clusters in other galaxies. We can see Orion Nebulae equivalents in other galaxies, which is really impressive. This is really cool. Okay, we're catching a guide star right now, and then we're gonna go. Let me make sure that I had my settings correct there, because that was a really good shot. Yep, 2 minutes. 2 minutes. Get your stuff together. Okay, we should have had our guide star by now, so off we go. Let's go back. So we're here, and we're going to be looking at the opposite end in a few minutes, which is this up here. We're going to look up here again, and we're going to actually look for, in particular, we're going to look at this section up here. This is the section of young hot stars that have formed in the galactic disk here of the Andromeda galaxy. We'll also see more detail in these dark dust lanes here. It's an exceptional night, I must say. And by the way, every one of these images will be available to you on the SkyTour LiveStream Facebook site, and there are up there now. When we did a wide field telescope view, we captured the entire galaxy in one shot and put that up for everybody to see. So that's something that you can check out as well if you like.
I was going to say, make sure this one, there's a lot of interest in this one in particular, so make sure that gets up there promptly, please. We're not doing a show tomorrow night, so there's no excuse.
That's correct, and I can't, unfortunately. I let too many things get in the way, and I couldn't get it done. And on Monday, we have to film a section or a segment for an A&E show here. So they're coming up from New York, and we're going to be filming all day. And I've got to prepare. We've got all kinds of filming equipment here that have to be set up. And it's going to be a madhouse, so I will not have time to do anything. On Sunday night, they're actually setting up for the Monday shoot. So I do my radio show here. I won't be able to do it. I didn't even think of that.
And we'll have more about that show when it's closer to a air date, maybe?
Yeah, we will.
Yeah?
It's a show. So. Yeah, they sometimes these guys, they come to, oh my gosh. I'm sorry. I just kind of lose it sometimes with this when I look at these images.
Mark, I have a question, a Skype question, you and Amanda. Okay. I'm sorry to interrupt.
No, go ahead.
Your pop-out chat started breaking up on me, and now the image of M31 is breaking up on me badly. Are you seeing that?
No, I'm not. I mean, no, I wouldn't, because
I have pop-up chat on YouTube as well. It's fine. Skype is fine. The visual is fine. Hold on. YouTube is fine.
YouTube looks okay to me, but Skype is breaking up badly.
Do you want to try to leave and join again?
Yes.
Okay.
Excuse me, I'll be right back, please.
We'll be waiting for you. Hey, Daniel Whitaker, good to see you. All right, Daryl has left, and then he shall join.
Ooh. Daniel had apologized earlier for being away for a while, but did he ever come back with an interesting question?
Well,
do you see this?
Yeah, Daryl's back. No, I can, but I'm read it to me if you could, if you don't mind.
Yeah, Mark, can you share screen again?
Oh, you don't see
it? Okay, that's better.
Should still be,
you should see it already there, Daryl.
Is it good?
Looks good so far.
Okay. Wow, look at this. What's Daniel's question?
Okay. And Daryl, listen to this, because we'll want your opinion too, okay?
Sure.
Since time slows as you approach the speed of light and then stops at the speed of light, if you could go back in time, are you going faster than the speed of light when you do? It's kind of a hypothetical, kind of.
Would you like to answer that, Daryl, or would you like me to take it?
That's an interesting question. I'd need to think about it.
Okay.
My first impression would be that you would probably blue shift. Either that or red shift.
Well, it depends
Go
who's
ahead,
watching.
What does that mean?
It depends who's watching you. Blue shift and red shift is a property of light. When you're coming towards someone at a very high speed, the light is shifted toward the blue, the higher frequency, because just imagine if you're coming, if you're running towards someone. Let me think of a way to imply this in a good way with an analogy. Well, you hear it with a train, okay? You can do it with sound. You can see how sound does the same thing. As a train approaches you, you hear the whistle, and it goes by, and that pitch change. That's because
Doppler effect.
That's right. It's the Doppler effect. The sound waves are being compressed as they're approaching and stretched as they leave. So it's like, okay, and that stretching is what Daryl's implying could happen with the Doppler effect of the light, because Doppler effect applies to light, but it doesn't change the pitch of light because there is no pitch. It changes the frequency of the light. Now, as far as hypothetical discussions of traveling faster than light, we don't ever consider traveling faster than light. Light is that's not a cop-out, I'm going to explain. Light is the speed limit in the universe, as we've said, but it's a speed limit for normal matter, okay? There is no normal matter, that can reach the speed of light, because at the speed of light, you would become pure energy, and no corporeal physical being like us could travel at the physical speed of light. It's a limitation imposed by the universe. And the physics, particularly relativity of the universe. And so if we were to, say, decide that we want to, let's say, travel to the nearest star, Alpha Centauri, and let's say we wanted to travel and could figure out a way to go faster than light, what would happen to us? Well, first of all, as we approach the speed of light, we in our spaceship wouldn't notice anything. One of the things that would happen is you get this thing that the transformation happens to your view. Everything starts to compress into the forward view until finally, when you are really like 0.99999% the speed of light, the whole space all around you is just compressed into a dot in front of you. So that's physically what you would see, most likely, if you could still even see. All right, but at the speed of light, then you would cease to exist. And the way that you could actually travel, quote unquote, faster than light is by avoiding it altogether. Now, what the heck do I mean by that? Well, very simple. I can show you with an analogy here. I have a paper towel, and I'll try to see if I can clear up the image so you can see this. If we consider that a paper towel is very much like a, say, space, okay, then what we would do is this, okay? Yeah, that's my ship office back there. This is a paper towel. Now, if the distance from this corner to this corner, wait a minute, let me also do this, make it a little bigger. The distance from this corner to this corner is, say, 4 light years, the distance of the nearest star. At the speed of light, it would take 4 years to go here to here. Okay, 4.3 actually. Well, what if you could bend the fabric of space? Space is a medium. That's another concept you have to get used to. And you could actually fold space. And so if this is the sun and this is Alpha Centauri, you could fold those 2 points until they come really close to each other. Jump across and then unfold space, and now you would have gone 4.3 light years without ever traversing the space in between. Doesn't that sound like a really cool way to go? Well, that cool way to travel was thought of in 1994 by a guy by the name of Miguel Alcubierre. And Miguel came up with a concept where you could actually fold space, and to do so would require an immense, I mean colossally large amount of energy. And that bending of space would take place once you had enough mass that you could use to generate this energy. And that mass at that time had to be a mass that's the size, mass that's equivalent, I should say, of the mass of the largest planet in our solar system, Jupiter, approximately. And that was just colossally improbable for even an advanced civilization. To make one jump, you're not going to use the mass of the largest planet in your solar system. You know, you can't acquire that kind of mass. That kind of mass. So what I would say is, if you wanted to do this kind of travel, you have to make a bunch of short little jumps, and you'd have to do it with a lesser mass. So enter another physicist named Sonny White, who works for EagleWorks Laboratories. EagleWorks is a NASA contractor. Sonny went through the calculations for the Alcubierre drive, and he figured out that you could actually use much less energy to make that jump we were showing you before with the paper towel. And the less energy you use, the more efficient your ship will be. But also, the less energy required means that it's more doable. Ooh. So what did Sonny come up with? He came up with a change to the geometry of the actual physical ship that Miguel Alcubierre had first thought about. And for the longest time, Alcubierre's design was just a thought problem. It became different, though, when White got a hold of the calculations, and he figured out that if you were to try and if you were to take the geometry of the ship's generator for this warp field that would be around, and it's called a warp drive too, by the way, because it does warp space. You could actually change that geometry of that driver that creates this warp field, and if you change the geometry enough, or to a certain point, you could end up using 10 to the 26th power less energy to make your warp field, basically. And that means going from, say, the mass of Jupiter down to the mass of something akin to the Voyager spacecraft. And that is the prospect that made it distantly plausible. Not plausible now, but distantly plausible. Someday we'll get there. Yeah, we're here, and someday we'll get there. Okay? So that's why NASA's funding research for this very drive. And I think it's a kind of a cool thing, you know. And Sonny White heads a program at his EagleWorks laboratory to actually do just this, to actually try to find a way, find a way to generate a warp signature, a warp drive using this folding of space technology. So it could come to us maybe within 100 years, or with any breakthroughs, maybe 50 years. I don't know. Oh, Danny fan. Amanda, thank you for putting up Alejandro's link. That was very kind. Alejandro, you deserve it, man. You the man. You the man.
We're all friends here.
Yeah, of course.
Yeah, he said Marianne and Tara always make him watch on the big screen. They twist his rubber arm.
I know it's boring, Alejandro, but look at this beautiful galaxy. How could you look at that, huh? How could you not want to see this galaxy with all this spectacular gorgeosity New word. Sort of like turbulated was a word I said yesterday, right? Well, this is gorgeosity now. So, okay, let's go.
I don't know, after you put your camera full screen, I never thought he'd show.
I know, I thought he'd run away.
That would lose viewers. I'm just kidding.
I think you're right. We're going to go to another galaxy before we head to Mars, okay? It's a companion, not a companion as in real companion, but it's a galaxy that is near, in space physically, near the Andromeda galaxy. It's called the Triangulum galaxy, also known as Messier 33. This galaxy is just about 2.72 light years to a million light years away, 2.72 million light years away. The Andromeda galaxy is about 2.4. They're very close to each other physically in space. Yeah, I know, Alejandro, you're a good guy. So what we're going to do is we're going to check this out, because this galaxy is what I call a mess. It's really a messy galaxy. It's one of these galaxies we're using Mirach as the guide star. You can see it up there. And then we go down to the Triangulum galaxy here. It's called an SC galaxy. That is, we classify spiral galaxies by S as capital S for spiral. And then we have an O for a tight one that doesn't look like it has any spiral arms, an A for very tightly wound spiral arms, B for more loose, like the Andromeda galaxy, and ours. And ours is a barred spiral. Don't worry about that yet. And then a little C, so capital S, little c, is this galaxy, the Triangulum galaxy. And the Triangulum galaxy's appearance is that of a loosely wound pinwheel. And we'll see it. And it's almost sort of not quite flat onto us, so it's sort of, you can see a lot of detail in it. And when we do this, you're going to see some amazing detail. You're going to see some of those hydrogen gas regions, like the equivalent of the Orion nebulas, the Tarantula nebulas, the Eta Carina nebulas, the things that are in our galaxy that are dominating our galaxy that we always talk about and see. We're going to see the ones that are 2.7 million light years away in Messier 33 in Triangulum. So let's just do a quick 25-second shot to make sure we have it. I always like to do a quick startup shot so I don't waste anyone's time. Terra has this UFO lamp that Alejandro is very good at balancing. It's a large pedestal, and then on top is this little spinning UFO. You should really check it out. I think that you're selling them on the UFO Congress site, Alejandro. Because Alejandro, of course, is tied in with the UFO Congress. Oh, look at that. And the UFO Congress is just probably one of the best conferences for UFOs in the world. And they just had it. Of course, it was virtual this year. It's a new thing for everybody, so new things are always a little different. But this time, what happened there was they had a lot of speakers from all over the world. They had Ket Thorvaldsen from Norway. They had other people from around the world, and then people that are familiar to them. I spoke there last year, and it's run by Karen Brard, who actually is very diligent about doing this. And I give her tremendous credit for what she's done. She's really pulled off quite a conference, to be honest with you. If you do ever get a chance to attend the UFO conference, make it the UFO Congress. Okay, the UFO Congress is the one to attend.
Don is wondering if the sombrero is near us. Is that doable tonight?
No, unfortunately.
No. Sombrero is in Virgo, just west of Spica. Spica and Virgo is set already.
Yeah. Check this out. This is just a 25-second shot of Messier 33, and you can see these little areas here. These are areas that are H2 regions, these ionized hydrogen regions that are star-forming regions. If I go a little longer, you might actually see their color too. So what we're going to do is we're going to go up, knowing it's here right in the middle. We're going to go up to a 2-minute shot. We're going to dare to do it. Okay. So this is a beautiful galaxy, and when I say it's an SC, capital S, little c, you can see why, right? We see the spiral arms, right? You know, you see the spiral arms very clearly are you know, these arms here. These are obviously distended and open, more so than the Andromeda galaxy. You can see them here. They're doing this here, okay. And on the other side, they're also doing that. They're kind of open. It's loosely bound, a loosely spiral galaxy. That said, I can tell you that this is just one of those galaxies, which is really interesting because see all these little dots in here, like these guys right here. These are not necessarily stars, and most likely not necessarily stars in our galaxy. These are probably globular clusters, like Messier 13 and Omega Centauri and Messier 22, that are in this galaxy 2.7 million light years away, you know. And there is something else down in this galaxy that actually is really colorful, and I'm hoping that our long exposure will show it, and we'll see when it comes up.
Okay, there's a slight correction. Okay, Don wasn't looking for the sombrero. Just wondering if it's a straight-on edge to us.
Oh,
It is.
Okay.
yeah, as is the Spindle Galaxy, or the Needle Galaxy. And we have actually looked at
I
the Needle
misinterpreted
Galaxy.
that, so okay.
That's
thank
okay.
you.
That's okay. This object right here that we're looking at is really a very interesting object. That guy. That is look with the color. Look at the color. We're seeing color, guys. A little longer does it. Now it's not quite guiding as well as it could have been. But let's just look at this. Look at the red color in the galaxy. Look at that. We can see these regions now showing up beautifully red. I'm going to do another one and make sure that it actually guides now. Ooh, I'm nervous. I'm excited. This is so cool. Wow. Look at that. Holy cow. You can actually see all this color. You know, there's an awful lot of color in this galaxy. And it's really nice to see it coming out. Check it out. Wow.
I'll be back in 1 sec.
1 second is over. Get back here. Look at this galaxy. I'm kidding, of course. Boy, look at that, Daryl. I know that it didn't guide well, but when it guides well, I can imagine it's going to be stunning.
Uh-huh.
Look at that. Here's, you can see the spiral arms, like right here. Look at the spiral arms. Here's the spiral arm. There's a big spiral arm. You see it out there. There's another one here. And they're just sort of circling around. Very loosely bound. This is another region out here of gas in that galaxy that's star forming. This is the biggest one in this galaxy.
I always liked that one.
Me too. Wow.
Mark, I don't mean to be a stick in the mud.
You're not.
Can we do Mars soon, please? I'm about to fall asleep here.
Oh, really? All right, let me just get another 2 minutes here. Not this. Let this finish. What I'm saying, and then we'll go to Mars. Yes. So the previous shot, which was only 25 seconds, looked like that. This shot, poorly guided by the telescope so far, probably in the middle of periodic error, looks fantastic. I'm coming back to this after the stream, and I'm gonna take a bunch of these and stack this. God, this can be beautiful. Wow.
Good night for it.
It really is. It's almost a red overhead almost. So you can't beat it. Okay, here it comes. Oh, not quite. Darn it all. Okay, I'll come back to it. I will come back to it. Oh, I don't want to leave it. Look at the colors. Look at the beauty. See, at a certain point, guys, when you start taking exposures of galaxies like this, at a certain point, because they're faint objects, they look mostly muted in their color when you're looking at them. But if you take a long enough exposure, there's a certain point where they just pop, and this is starting to reach that point. Hi there, Prow. How are you? Hey, Papa Tom. And Alejandro Rojas. Awesome. Okay. All right. Now let's go do the stick in the muds. You're certainly not a stick in the mud, and you know that.
Maybe I'll get a second wind like you got a sixth wind the other night.
I did, didn't I?
You did.
All right, I'm going to have to go and make sure Mars won't be blocked by the dome. When we roll the roof off, won't have to do this, but I'll be right back, okay?
Okay. I'll try to entertain people.
You are good at that.
Shall I sing tonight? I probably shouldn't. I usually need to be drunk before I sing. Oh golly. Mark asked earlier, somebody asked earlier about especially cool things I had seen. One, it might be a little off color, but at another star party I was holding down in the mountains a long time ago, I had 3 telescopes set up. I had my three, I think it was 3. Had the 5-inch. I had what I guess was one of the 8 inches, and I had a big old 16-inch light bucket Dobsonian set up. And there was a girl there. She was a summer employee at the park, state park, and she took over the 16-inch, and it was really funny. I just watched her and let her have at it with the Dobsonian. It was a big old ugly pig of a telescope, and she was riding that telescope like a horse. It was something to see. She found some really cool things in it that night. I went over to take a look. She was way down in, she was, I think, if I remember right, between Sagittarius and Scorpius, down below the center of the Milky Way. And she found some cool stuff, but boy, she took over that scope that night. It was funny. And she really was. I mean, she had one leg wrapped around the telescope. Pretty funny. Welcome back. Mark, are you there? Okay, folks, Papa Tom, yes, I think so. I don't know if you all could even hear me at this point. My screen is breaking up really badly again. Tell Mark that I'm leaving and I will be back in a moment. See if that resets it.
Okay.
Hello, Mark. Can you hear me? There it is. I had to leave again, but I'm back.
Okay.
There he is.
Sorry
about that. I had to leave too, Mark. My Skype started breaking up again.
Okay.
Yeah, I'm starting to close Windows too because it looks like my memory usage is starting to spike. If it drops out on me, you'll know where I went. I'll try to come back as fast as I can.
No worries.
But I'm here for now.
All right. Okay, we're at Sheraton, and that's going to be our guide star, and we're going to use that to get down to Mars. There's Sheraton. Hi, Sheraton. And then you'll see it zip away as soon as it's auto-centered by the telescope.
And I'm back.
And there it goes. And now we should see Mars. That ain't Mars. Maybe it is. No, it's another star. It's using for a guide. I guess Sheraton was not. It's going to Hamal. Okay, so maybe it didn't like that guide star. Okay, that's not correct.
Uh-oh, starting to act up again?
No, I think that the guider. That's why it took me a while. The guider. That's why I hate domes. The guider and there's 3 telescopes out there. The main scope, the guide scope, and then there's a smaller scope that's used to help find other objects. And it can't find Mars, okay? So I'm only because it can't. The dome's in the way. The dome has blocked it. It's an odd angle. So what we're gonna do is I'm gonna go to Sheraton. All right, we're gonna just go to Sheraton. All right. Look, there's Uranus. Uranus is here too. Let me get us up here so I can show you. Okay, now there's Sheraton. That's the star where we're going to be. And then I'm going to move us from this position of strength, one we know where we belong, where we are. Where'd it go? Is it using another star to find Sheraton? No. Something that goes on, which is weird. I told it to go to Sheraton, and it's going to Hamala. Hamal, rather. Hamel, if you want.
I think they say it Hamal.
Yeah. Now it says that's Sheraton. So let's make sure it stays there.
When you see Hamal and Sheraton in the sky, folks, that's Aries. Hamal and Sheraton are the 2 bright stars in Aries. It's a fairly nondescript constellation, but it sits between Taurus and Eastern Pisces. They're pretty recognizable once you get used to them. They were up in the northeast this time of year, a while after dark. And if you're in Aries, there it is right there.
Now it says it's Hamal. Yeah. Well, let's take a look at Hamal.
Could you sync on Hamal? And
Well, I'm not convinced it is Hamal yet. But here's how I'm going to fix it. I'm going to actually drive us down to Mars directly. All right, and see if Mars comes into view like we think it should. And to do that, I'm going to give us a little bit more oomph with the telescope. All right, so now if I take us toward the south, okay, you see the scope icon moving down. Okay, and then we're going to head a little toward the west and toward the south again.
it's interesting. When you told it to go south, it moved southwest.
Well, remember that we're looking at the alt-azimuth lines. We're not looking at the equatorial lines.
Oh, okay.
So now let's see if we can get it in here. If this doesn't show, I will use a different technique if I can. I just see it? Yeah, it's behind here. Okay. Alright, so I have to tone down our speed. And now let's go toward the east a little bit. And is it going to be this one or this one? I can't tell you. I don't know yet. Let's do this first of all. There it is. Okay, so that was Hamal. Alright. Now we're going to drop out of bulb here, and we're going to go down to singular seconds, fractions of a second actually, and we're going to go down to 50 ISO here. Okay, 50 ISO is what we're going to use because that's going to be very low noise. So there we are, and then we're going to drop this down. Our exposure time is going to go to a fraction of a second. You'll see that Mars is now turning more red. Okay, so let's try a 13th of a second. This will check our focus. And now we're going to zoom in so you can see what this thing looks like. Okay, it looks to me, well, even the way it is, we actually see the southern polar cap is there.
Yeah, southern polar cap.
Polar hood is there.
Uh-huh.
And we will do the following. Looks like I should probably focus it a little bit. It looks a little out. So, to focus it, we will do our typical focus structure here. We're going to go in and do this right here. And now it's there. And let's go and let's actually change the speed here so we can do micro adjustments. That's better, just a little up. And now let's head to the west. Okay, and now what I'll do, you can see how turbulent the air is. Okay, this turbulence relates to a factor we call seeing. Tonight is a night that has high transparency. You see transparency and you see seeing. Transparency is how clear the air is. Seeing is how turbulent the air is. And we see some turbulence. It means you're going to take a lot of photographs to get something looking really clear. So now we're going to focus. And to do that, I hit a focus button that you can't see because it's hidden behind the behind this screen. Okay, there it is, out of focus. Oh. Let's do that for a second, see what it looks like. Alright. Okay. Let's go check it out. Where is the red planet? Red planet! I want to see the red planet. Yeah, that's a red planet. Okay, I got better focus to do here. And we'll do it. I have my lights on a timer in here. They kind of went off, so I have to turn on the lights again. Okay. Right, let's do this. And then, just a minute, guys. Like that. And no, turn that one on, and then do this. Here we go. Okay. I have to be able to see too, and I've got to have the illumination on the keyboard down here. Okay, so now focus, assist. Whoops, and then that. All right. All right. Okay, and now let's focus this guy again. Okay. Okay, I think this is pretty close, but we got the night has got poor seeing, unfortunately, so it's making it a little tougher. Okay, we can't look at that and say, oh, look at all those clouds. It's not clouds, those are artifacts. Yeah. Let me actually drop the exposure a little bit. Okay. And get rid of this, and now I'll do it again. I don't see the same quality here as we did last night, Daryl.
Yeah.
You know, the seeing is definitely a little off, as you could see. We come back and look here, and we look at it in the magnified view. Did Amanda stay here? Is she still here?
I think so.
Oh, okay.
Yep.
Because I didn't hear you since I came back in, so
I announced I was back a while ago, but
oh, I must not have heard it.
no, I've just been typing away.
Hello, Wolfie. How you doing? Wolfie Attori is in the house. Nice to see you, man. And Genghis is here, huh? Oh, there he is. Genghis Khan. What's going on? Yeah, so Mars is just a little bit of a poor performer tonight. Sorry about that.
Oh, well.
The transparency is actually pretty high, Terra. I would say that the transparency is probably a 4 out of 5. But the seeing is probably a 2.5 at best. Because there's turbulence. Although, that's this part of the sky. In the other part of the sky, the seeing can change. And when we looked at the galaxy we were just looking at, this galaxy was just... I mean, look at this galaxy. That's not the galaxy. Let me get rid of this focus helper and get rid of this. Given some care, I could probably get a really good set of images out of the Mesher 33. But I will do that. But I'll wait. I'll do that after we're off the stream. We've been going for almost 3 hours. So what I'm going to do is I will go into my photo mode in my head, where I'm going to go and start doing some research work. And I'll leave everything going. I guess I could leave the stream going, but officially I'm going to cut the stream here in terms of, trying to say what's going on and everything. And I'll just go in and start taking imagery of the galaxy. If you want to sit and watch, I'll leave it going. But if you want to go, that's fine too. But we'll basically say that tonight's stream is going to be over by, in these next couple minutes here. So I want to thank you guys for coming. If you want to hang out, we'll call this sort of like the after hours behind the scenes. and you can just hang out and watch. But I won't be as talkative. I'll be focusing on what I'm doing here. Daryl's tired. He said so before. So, Daryl, if you want to head out, you go right ahead. Amanda, you can if you wish.
What's going on? You're staying to take pictures?
I'm just going to stay and take pictures, but I'll leave the stream running because I know Daryl wants to go to bed. He's tired. So that's fine. So I'll just hang out. I'll take more pictures, and I'm going to go back and go to some objects that I'd like to go to. And I'll keep looking at the chat, and see if you guys are still there or whatever, and that's fine. But
a few people would like you to keep going. A few people are just getting here, actually.
Okay.
I don't know. Does that mean if you have specific objects, does that mean the request line is closed for the night?
I'm going to. Well,
requests?
Not necessarily, but it's almost 1 a.m. and for the next half hour or so, I'm going to just take pictures of the galaxy so that I can have a second set of images to stack. You know what I mean? Because that's going to be a nice thing to do. I think that'll be great. All right. So we will do that. So this saying we're in triangulum now.
Sorry to be a stick in the mud tonight.
Oh, not at all. You've been great.
Yeah. Mars was a bust.
It was. We looked at it and the seeing was poor. But I guess we gotta do what we gotta do, Daryl.
Yeah. Well, have fun with M33.
I'm going to.
And I'm going to call it a night then. Good night, everybody. Amanda, Mark, you all take care. And
okay, Daryl. Thank you.
I guess no show tomorrow, so I'll see you all sooner or later.
Yes, you
Have
will.
a good night.
Good night, Daryl.
Okay, good night, Daryl.
Good night.
See you later.
Bye-bye, everybody.
And good night to all those leaving. I see a few people are gonna head to bed now, but a few people are willing to stay around, so...
Yeah, it'll be a smaller group, but we have 40 watching now, so I figure if they're interested in sticking around to see what we've got, well, then that's fine. I'm just going to give us a 25-second shot at 25,600. Make sure that the triangulum galaxy is in our image field here. And as I said, I won't be as talkative, but I'll talk to you, Amanda. And
Okay.
I mean,
Well, I'll keep my eye on chat.
Sure. I mean,
you guys have any questions?
I'll just be less attentive to looking at the chat. But if you got anything that comes in, I'm certainly not going to avoid it.
Yeah.
They come here to watch this stuff. Oh, we got it. Look at that. Okay, so that 25-second shot looks good. Yeah, telescope spectrum performing well. So let me go do. I'm going to do through the settings here. I'll keep explaining what I'm doing too, in fact. So,
well, I was gonna say I was gonna send you some articles, but since we're not doing a show tomorrow, now I don't have to worry about it. It frees me up for some videos I have to do before Monday, but I could take a peek and see if anything of interest is going on. See if maybe you've heard about it already. If you have any thoughts on certain things.
I'll talk about.
Of course, if anyone
thing.
in chat has any questions, you guys come first. But if Mark's gonna be quiet, I have nothing. So.
Yeah, but me being quiet, I mean, I don't even know what that looks like. But the other thing is, the one thing that I did want to mention to you guys is that we've all heard about Venus and the potential for there being some type of life in the clouds on Venus. Now, interesting that we come up with that because it's something I've mentioned years ago that maybe Venus has a certain type of evolved life form, not evolved as an intelligent, but just a life form that has come to arise that is living in the cloud tops of Venus. And now, how would that look? What would that be like? Well, it could be microbes wafted on the air and have certain ecosystems based on the stratification of the layers, because Venus has a very, very heavy atmosphere. So I can imagine there'd be some fairly stratified layers where, just like with our atmosphere, if you come in fast enough as a meteor, you hit a wall. And that wall is like at a certain point in the atmosphere, a certain altitude, and it will literally cause the meteor to explode. So maybe there is a similar wall, chemical wall, but on Venus, whereas not here. It's just density, and these particles, like balloons, will sit on the surface of water if they're filled with just air. But they won't sink in the water. So maybe there's a life form in the Venusian atmosphere that is actually floating in a similar way above a certain density of atmosphere. This all came from looking at something called a phosphene. There were phosphenes seen in the atmosphere of Venus, and the thing with phosphenes is they shouldn't be there, because a phosphene is something that can only form in the presence of life. So it's a little bit odd to find these phosphenes, and so because they're there, we have to think, well, how in the heck did they get there? So that's really kind of a cool thing. And so that's the latest thing that I've been really checking out,
Sorry, I'm just looking for
That's okay.
video from Daniel Whitaker. I think I found it. He actually sent us some video. Well, I say us. He sent you a video on our SkyTour Radio at kjraradio.com email. He wants you to check out some video. I forget who it was. Someone, young lady he knows, took some video of what they think might be a UFO, and Third Phase of the Moon actually covered it a little bit. So I'm trying to get the video, and I think I have it.
Okay.
Daniel, you can let me know if this is the video. Again, it's Third Phase of the Moon, so take that with a grain of salt.
Well,
that's
actually,
no disrespect to the videos and pictures Daniel submitted, but who knows what they did with it. So Mark will take a look at it, hopefully, and let you know what he thinks.
I will.
Yeah, he's the chief video and photo analyst for MUFON, Mutual UFO Network, so he knows what he's talking about. And unfortunately, sometimes it's just, a lens flare or a bug or a reflection or light. But sometimes you can't explain it, and you need other people's opinions. So
that's true.
I figured you would have talked Venus to death by now.
No, I'm actually reticent to discuss it a lot, because I think that there's a lot that we have to look at with Venus, and I'm really not sure. Actually what we can expect to see, and what might be true or not true, So let's see here.
Well, good news, I found the right video. So that latest YouTube video I just put in, that was the Third Phase of the Moon video, and the first story is the one Daniel submitted the pictures and videos for. So I haven't seen it, I can't speak to it, but
okay.
Check it out. Check it out at your own leisure.
All right. All right, let's see here now.
You said you were going to be quiet. I
can't.
I got nervous, but now I'm really panicking.
Why?
Dead air kills me.
Oh, I know, but you know what? It's not dead air. There's music. Sometimes people like to just have nothing, droning in their ears, and they like to just listen. I'm aware of that. I know that it's not easy having to listen to somebody and think you gotta pay attention to them. I don't want people to feel like they have to pay attention to me at all. I really don't. I think it's much better if they don't have to. By the way, I'm bringing this back because I know that it went away. Do you see it?
Daniel wants to know if you heard about them sending a robot to Venus to harvest the clouds and bring them back.
I have not heard about that.
I have not heard about that.
I think that would be kind of an interesting concept, but what would they bring us back?
I don't know.
Yeah, I don't know. But hey, it's worth a look. I think that Mars is probably thank you, Tara. I think Mars is probably a better bet for us because Mars is a place where you could more likely find actual life that might be more substantial. Give you an idea. If you listened to SkyTour Radio, was it last week or the week before we talked about the Perseverance rover? Do you remember that?
Sure.
Okay.
Yeah.
Perseverance is on its way to Mars now, winging its way to Mars. We're not going to hear about it until February when it gets there. But then it's going to land using this sky crane maneuver, the same as the other rovers in some cases. And it's a complex landing system, but it's worked every time so far. So we're going to try that out again. And the best thing about this whole process is that the Perseverance rover, God, that's beautiful, is bringing an entirely new suite of instruments. Currently, the most reliable and most complete laboratory on Mars rests within the Curiosity rover that's been tooling around on Mars since 2012. Now, if you think about it, it had a 90-day lifetime, and it's been there since 2012, continuing to tool along. JPL builds things great, let me tell you, okay? They really do a good job. So hey, that's not a bad bit, Not a bad bit at all. So, what that means is that we're going to find that we have new instruments on Mars, new capabilities, and these capabilities will include, and not be limited to, generating oxygen from the Martian atmosphere. Now you might say, well, wait, I know there's no Martian oxygen. And that's true. There is no oxygen in the Martian atmosphere at all. Okay? However, the atmosphere is mostly CO2, a carbon atom, and 2 oxygen atoms. So you might say, well, wait, can we use that CO2 and maybe split one of the oxygens off and maybe make some O2 like we breathe? And that answer comes from an experiment that's on its way. It will be delivered to Mars by Perseverance. It's called Moxie, Mars Oxygen In Situ Explorer, and something like that. And what it's going to do is it's going to take the CO2, take 2 CO2 molecules, and it's going to create a couple of CO molecules, which is carbon monoxide, and some O2. Okay, and then that's the thing you want. That's the magical piece. The rest gets released, and okay, back to Mars. So we're talking about some really interesting experimentation, and the rover, the Perseverance rover, is the first rover in history that is going to Mars expressly to do preparatory work for human exploration of Mars. So when it gets there, it's going to be taking pieces of astronaut helmets, pieces of suits and space suits, and it's going to be exposing them to the Martian atmosphere and see how it works, see how it acts, see if there's a problem. And that's like, wow, we're getting serious, man. And we are. I think you better get used to the fact, folks, we're going to Mars. And everyone watching this stream tonight, I can tell you probably with certainty, near certainty, you're gonna be alive when we get there. You'll live to see it.
Look, I see a perfect little setup here. Yuffie says, Mars, so far from the sun. Where will the energy come from for terraforming efforts? Are you going to tell her about the blanket?
No,
I hope she likes the blanket.
I'm not. You are.
Why? I don't know anything about the blanket.
Yes, you do.
Not really. I don't know what it's made of. I don't know how we're going to get it up there.
Neither does NASA. NASA doesn't know. But, okay, where will the energy come from? Well, obviously, the energy is going to come from us generating some type of energy, of course. You're right. But to terraform Mars, we're not going to... First, we have to define what terraforming means, and we're not going to actually affect the planet directly. Because how would you terraform a planet? What do you mean by terraform? The definition of terraform: make it livable for humans. How will we do that? Well, how are humans kept alive here on Earth? Atmosphere of oxygen. Okay. Thick atmosphere that protects us from the ultraviolet radiation from the sun. Oh yeah, need that. Magnetic field to trap the ultraviolet radiation. That's part of the safety net we have. So that is the issue with Mars. Mars doesn't have a magnetic field. Nothing reliable anyway. It lost its magnetic field. It used to have one, but it lost its magnetic field a long time ago. So what do we do? What do we do? What we do is we create a way to generate a magnetic field and then drape it around Mars like a little bit of a blanket. Now, how can we possibly do that, and how do magnetic fields drape? Well, if you look at the Earth's magnetosphere, the magnetic field of the Earth, and how it's affected by the sun's rays hit our magnetic field and they push it, and it drapes back, leaving what's called a magnetotail. And we're inside of that because we're generating a magnetic field. But if we could generate a magnetic field out between Mars and the sun at just enough distance so that we can generate this magnetic field here, and then make it a huge magnetic field, and then the sun's energy will drape it around Mars. It'll be like a protective blanket. And Mars will then have a chance to terraform itself. What do I mean by that? Mars can terraform itself because it's always making little bits of CO2 and oxygen and water. But the ultraviolet light from the sun currently is unimpeded, and it gets down to the ground. And it rips apart water molecules, turns them into its constituent atoms, hydrogen and oxygen. The oxygen, traditionally over billions of years, has gone down into the soils of Mars and bonded with iron compounds to form things like hematite. What does that do? Well, that's rust. And that's why Mars is red. And for any of you out there that are saying Mars is red because it rusted, and you're just getting it now, let me know in chat. But Mars rusted, and that's why it looks the way it does. Okay, various forms of hematite, which are iron-based compounds. And one of the things to keep in mind is that these iron-based compounds on Mars love to bond with oxygen, and oxygen loves to bond with them. So when the oxygen was split apart from the water molecules, it jumped down into the soils where it bonded and did this to Mars. You undoubtedly could reach dark rocks on Mars. All you have to do is dig down. And the InSight lander right now is the only one that's actually doing a mining expedition on Mars. It's actually digging straight down with a probe. The idea was to get it down, tens of feet into Mars, and for the longest time it kept just bouncing back out of the hole. It couldn't do it. And the reason it couldn't do it was because maybe they had a rock in the way and they just didn't realize. I mean, it was a long shot. However, guess what? They managed. It's working now. They're actually drilling deeper in Mars, under Mars's surface right now, thanks to that project. So that's pretty cool. It's a little tiny probe, and it's really not very high tech relative to like a fancy drill from like an oil rig or something. But it is doing the job. It is doing a job, and is doing it well.
Ginga said he read something about satellites being used to strengthen the magnetosphere.
Yeah, I mean, there's a lot of possibilities, and in reality, we wouldn't have just one object that's making this magnetic field. We'd have a bank of them, a lot of them, and maybe we're talking about these satellites. But I mentioned you'd put these satellites between the Mars and sun and the sun, and probably just like at some distance from Mars, maybe 500,000 miles or something, maybe a little more, and we would generate the magnetic field, be so extensive that it would then be draped by the sun around Mars, and that would protect the water that's being made on Mars. That would protect the water from being disintegrated by the ultraviolet radiation from the sun, because the magnetic field will trap the ultraviolet radiation, the high energy particles, the solar wind, and prevent it from reaching the Martian ground, and that will save those molecules from being destroyed, and allow them to build up in the atmosphere. Now, if they do build up in the atmosphere, then the Martian pressure on the surface will increase, and that's the stopping point for why, for instance, we don't have and see water on Mars, is because the pressure is too low, the temperature is too cold, the atmosphere is too thin, meaning pressure is too low. So that said, if we can allow the water vapor to build up in Mars, we'll have clouds, which will tend to help create a greenhouse effect, which could warm Mars. And if it gets a little thicker, not much, okay, but if it can get a little thicker, then we will end up seeing water in standing pools on Mars, and maybe we can return Mars to its former watery self, and I think that would be pretty cool.
I hope that answers Yuvi's question too, on how to create the magnetic field.
Yeah, I think he wrote another question. So, well, no, I didn't answer how, because NASA doesn't even know yet. It's just a mission on the docket right now, and it could be satellites. I think it was Genghis that said that.
The magnetosphere was Genghis.
Yeah, and by the way, where do we put these satellites to generate this magnetic field for Mars that would then become Mars' magnetosphere? We put them in what we call a parking spot in space. Well, what do you mean parking spot in space? How can anything park in space? Well, the way it parks in space is by going to a location where all of the forces of gravity sum to zero for these locations. These are called Lagrange points.
I remembered that.
Mm-hmm. I bet you did.
I remember that.
And these Lagrange points are places where we would actually be able to do exactly this: park spacecraft or multiple spacecraft, and they would just sit there, being tugged equally by everything all around them. And we use Lagrange points now for our satellites in some cases, and I think that they're very useful. And you only need a very little amount of fuel to maintain your orbit. So I think that we're talking about a Lagrange point effort here, you know?
Yeah.
Yeah.
And while we're on Mars, Evie wants to know if Mars's core is nickel iron like Earth, and if so, does it spin? What creates the Earth's magnetic field?
Yeah, we think Mars' core is somewhat similar to the Earth. But on the Earth, we have a solid inner core, okay, kept solid because of the pressure on it. And outside that is the outer core. And that outer core is actually liquid iron. And it is moving against the inner core, and that actually creates a dynamo and generates massive electric fields. These massive electric fields, my nose has been so itchy tonight. Those massive electric fields are translated into magnetic fields. All right, because an electric field will create a magnetic field. In looking in elementary physics, you can see how that works. And so making a magnetic field from electricity is not the hard part. Maintaining it is. And over the billions of years, Mars' outer core, if it really had an outer core, ended up cooling off. Mars is a lot smaller than the Earth, so it cooled off after a while. And that outer core began to become less molten and more, I won't even say solid, but more plasticky. And so it didn't have the ability to manufacture a magnetic field like the Earth for a long period of time. So we have to help it. We have actually got to go and create one. We're going to create a magnetic field at Mars. Now, if we did that, Mars could end up, over time, having a habitable atmosphere where you might not need a spacesuit. You just might need an environment suit like they wear in Antarctica. It's going to take a long time, but you might, if we can build the pressure up at Mars, you might find that the ultraviolet radiation is trapped well by the magnetic field that was generated by these satellites or magnetic field generator at the Lagrange point. And you might just need to have a little oxygen tank, supplemental oxygen. You wouldn't have the low pressure anymore if we could terraform, or if Mars could terraform to that point where it has enough pressure. Literally, we're looking at right now, Mars is less than 1% of the Earth's atmosphere. Got a long way to go. But it's okay, because even though we have a long way to go, I think that we would find that we would be in really good shape if we could actually create such a magnetic field.
I know, we have tons of questions coming in, and I'm being a terrible distraction. You said a few more minutes, we're going to be here hours, and you still won't have your pictures taken.
Oh no, I'm taking them. I'm talking and taking them. While they're taking, I'm talking.
Okay, well, we'll try to touch on a few.
5 more minutes of pictures here, and then I'll probably. It's such a good night, though. I really hate to go to bed.
Famous last words. When the sun comes up, it's officially over, because then we won't be able to see anything.
Well, wait, I have a solar telescope.
Oh my god.
I do. I can see the.
I know you're not joking.
I had it on the telescope for a while, but.
Oh.
Go ahead.
What? So you'd be saying the Earth requires the moon to create the Lagrange points. So are we using Phobos and Deimos? Are we using Mars's moons for their Lagrange points?
Actually, even without the moon, we'd have Lagrange points. There's Lagrange points all throughout the solar system around many of the planets, obviously. But we don't need the moon to make Lagrange points. It's just another gravitational force we have to contend with. If anything, it makes Lagrange points around Earth a little more difficult to maintain, because the moon is always moving. It's always, it's slightly elliptical in its orbit. It's not perfectly circular. So planets that don't have anything around them would be easier to deal with, because the only other thing you have to worry about are other planets much further away, and the sun. Different variations, different amounts of parking fuel, if you would be used to hold them in their position if necessary at all. They could use solar power to generate some motion as well, because there's ways to orient the spacecraft based on spinning wheels called reaction wheels on satellites. Kepler used them, and so we could do that to just not move through space, okay, But we could use it to create a beautiful galaxy photo. I'm sorry. Yeah, it's just, oh, wow. I apologize. Sometimes my thought process went to, what if there are civilizations in this galaxy looking at us? And here I am taking pictures of their galaxy going, wow, you guys are beautiful. Anyway, so, where was I?
I don't know. Lagrange points?
Yeah, I kind of...
Mars?
Yeah, yeah. No, I was saying, that the Lagrange point, the moon isn't needed for the Lagrange points. There are Lagrange points around others. And Phobos and Deimos are really small, but they do have a gravitational field that would have to be worried about. If they're big enough to be held by Mars, they're big enough to affect the Lagrange points. So you'd have to worry about how their combined influence works on the spaceship out there. We literally have to consider Jupiter more than other planets in the outer solar system. Jupiter is the kingpin, and it's the biggest gravitational force in our solar system other than the sun. So in an elementary
What's the latest
way,
count on Jupiter's moons?
I think that the number is, I could be wrong, I think it was 69, 68. Some of the chat's
I thought it went up by like 25 since then. I thought it was in like the 90s now or something.
I thought that was Saturn that went up by 20.
Oh, I don't know.
But yeah, we can find out.
Yeah.
Actually, Google.
Well, we have a few more questions from chat while
That's
we're
good.
here.
That's
I can
fine.
look that up later. Daniel's wondering if you could take all the iron from hematite and make a magnetic space web for Mars. I don't know what hematite is. I don't know if I'm pronouncing that right. Sorry.
You are. Well, hematite in its very nature is a ferrous material, meaning that magnets would react to it. But you have to have a magnet to work on it. It's not magnetic in and of itself. So we would need to actually have something that generates a magnetic field or is magnetic, okay? So just having hematite isn't going to do it. We need to have, a magnetic field, and it's possible the magnetic field could operate on hematite, but it's not like it has to. It's not like it's going to actually make the hematite have anything to do with Mars' magnetic field. So it's. I understand where you're going with that, Daniel, and that's a good prescient question. But we don't have any. Whether it was hematite or not, we still need the water vapor to not be destroyed when it's being made on Mars by the processes that happen now. Because Mars has a lot of regular water on it, H2O. It's frozen solid. The Phoenix lander, when it landed, underneath the Phoenix lander, it landed on a dusty coating of Martian surface, and the thrusters pushed away material, and literally that far under the surface was rock hard as granite water, ice. Okay, so a lot of the Martian water is tied up in this ice. Yet under the south pole of Mars, at a depth of I think 12 kilometers, there's a several kilometer long lake that has been identified underneath the Martian surface. Now, we know that life finds a way, and we know that when you talk about having a system on Mars where only microbial life could exist at this point, that it's probably microbial life we're talking about. But this life on Mars could actually be several kilometers below the surface in complete darkness. We would not have thought that life could exist down there as fervently as we do had we not found the sulfide chimneys on the ocean floor. There, in perpetual darkness, there is a virtual menagerie of life down there. I actually have a piece of one of those black smoker chimneys here, given to me by the Woods Hole oceanographic folks. It's really just an amazing thought process to think about how those formed, and in complete darkness, life has found a way. And they don't use the sun to make energy, right? That is called photosynthesis. That's what the plants do in the world of the light. But in the world of the dark, you have to use chemical processes to make energy as a life form, and that's chemosynthesis. I actually talk about that in my book, The Populated Universe. I talk about photosynthetic versus chemosynthetic life and what it means for us to have found chemosynthetic life. It's why we think there could be life under Europa's ice too, you know. So it's really quite an interesting finding that there's this lake under Mars. Hang on, I just gotta say a message here. Write a message. Okay.
And a hypothetical here.
Okay,
if we ever get a plan together to terraform Mars, Isabella wants to know how long this could take.
Oh, Isabella, $1 million question. If we could do this blanket of magnetic field, make a new magnetosphere for Mars, an artificial one, we would see changes in 10 years. Not changes that would allow us to live there, but we would see changes to the atmospheric constituents of Mars, more water vapor, thicker clouds, and in just 10 years. So it would be pretty quick because Mars is always doing this, and Mars is always losing its water. And the hydrogen's going to space. Little by little, Mars is losing mass. It's just not pretty, you know. But let me tell you, that's actually an awesome idea, you know, to terraform that little bad boy, and I don't know, we should go there. I know, make it a prison planet, and that'd be the prison. Send them there and they can't get back, so we're cool. No, I'm just kidding. My luck, you know, I get jailed for something I didn't do, and now what do I do?
Okay, so just to clarify here, could a web of Mars sats use the sun, solar, wind, or high energy particles to create a web of magnetic fields? I can't talk anymore, guys. Is that what you're thinking about, draping stuff?
Oh, I see. Well, you have to put this web of satellites in Martian orbit. Okay. For sure.
Is that, in your opinion, the most logical way of doing it, or what of all the
I think the
theories
Lagrange
do you like the best?
The Lagrange point is probably the best, because we could find the energy to generate a magnetic field without a doubt, and we don't have technology to do that yet. But we also don't have technology to put an absolutely stupendous number of satellites in Martian orbit. They'd have to be launched from the surface of Mars, which means we'd have to have a hell of a forceful presence on Mars to actually have that and the infrastructure to make the fuel. Now, the Moxie experiment from Perseverance has another really cool thing, and that is, hey Wise-Eye, how are you? What was I going to say? The Moxie experiment is going to create oxygen in a test, and it's a car battery size object. It's a fraction of the size of the full size thing that would be used. But this Moxie experiment will also be creating oxygen for another purpose. And do you remember what that other purpose was, Amanda?
The other purpose of oxygen?
On Mars. What's the other purpose of the oxygen on Mars? It's not just for us to breathe. There's something else too.
Create the atmosphere?
No, that would be something for us to breathe.
No, that's okay.
It's not something for us to breathe. It's something different. What is
So
it?
I guess it's not for plants or water or
No.
to produce the carbon dioxide.
No. Yeah, we talked about it on the show, and it's okay if you don't remember. I'm just
I'll
saying.
remember when you tell me, I'm sure.
You will, I'm sure. It's actually to create rocket fuel.
And okay, I don't remember that.
Okay. Yeah, it's to create rocket fuel.
Why is that essential?
Because oxygen is very important. You know how you have liquid oxygen tanks and liquid hydrogen tanks, and they create hydrazine. It's a fuel. It's very corrosive. It's also very dangerous. But the fact is, without it, we ain't going nowhere. We can't come back from Mars if we actually go to Mars. We're not going to get away from Mars, and we would like to come home. It'd be nice to come back.
Yeah, that makes it a little more essential. I wasn't thinking that. I was thinking like we're moving there,
Yeah.
Yeah.
Yeah, exactly.
So I can see why, the breathing and the atmosphere, that might be important, but rocket fuel, no, that wasn't on my radar.
Yeah, no.
I wasn't thinking that.
Yeah,
but yeah, no, it's an excellent point. Your screen's glitching all over the place.
Oh, you mean this here?
No, the whole screen on Skype.
Oh, that's odd. You still there?
Yeah, I'm here.
Okay.
No, I was just checking YouTube. No, everything looks good.
Yeah, no, we're still in business. Screen. Let me see what the stream health looks like. Excellent connection. We're doing excellent. We have an excellent stream health here.
No, it's just the screen you're sharing on Skype.
No, I know, but
that
could be
disappears totally for a second. But yeah, no, YouTube is good.
That could be affected by the connection.
Well, our good friend Bill warned me that a hurricane might be potentially heading my way by Wednesday, so could be on my end.
Oh, it's gonna hit us first.
Mm.
Don't forget that. And it's totally clear here right now, and the sky is just absolutely stunning.
Yeah.
I can't go to bed. I need to go to bed. I'm tired, but I can't.
It is 20 to 2 for you.
Shh, don't
Please
say
you
that.
care.
It's too beautiful here. I can't. This is one of those rare nights. One of those rare nights where you just.
Well, very often you plan to stream and then the clouds overhear you and make other plans, so
Yeah.
I get it. When you have an opportunity, you gotta take it, so.
Yep.
And that's why it's so important to hit the bell when you subscribe. Because you never know when we might show up.
That's true. And that's the one thing. This takes my breath away every time, Let me just count my images here. 1, 2, 3, 4. Okay. 5, 6, 7, 8, 9, 10. Oh, good. 11, 12, 13. Okay, we're going to have 13, 14, approximately 14 of these to stack. You know what, guys? I got to just share this with you. This is the last image for tonight because I officially must call it quits for tonight. But I can tell you right now, you look at this galaxy here, and what I see when I look at this galaxy is...
Which galaxy is this?
This is Messier 33 in Triangulum. What I see is a galaxy that actually stands a chance to harbor lots of life. Look at these amazing dark lanes. The night is so spectacular. I shudder to think what'll happen when I start processing these. I won't do anything. I won't eat. I won't do anything. I'm going to process these. I'm worried I'm going to do it tonight too. I can't do it tonight, but I want to do it tonight. Look at these images. Wow. Look at this beautiful hydrogen gas region up here. You know, look at these beautiful here, here, and here, and over here. Look at these little tiny dots, which are globular clusters in this distant galaxy. Look at all that. Is there a life form there? Looking back here and going, wow, I wonder if there's life in that weird galaxy over there. We've never seen our galaxy from outside. Ever. Wow. I'll leave you with those thoughts. Well, folks, I've had a great time. You've been amazing. I have so much more I want to do, but I can't. The only thing I'm going to do now is I'm going to change my filter here, and I'm going to go to what's called a dark frame filter, and I'm going to take images of nothing, because that's what you do as a last step in taking pictures like this. Okay, you take images at this temperature and time, okay, of just the blackness, and this gives you, all right, so here we go, and this gives you the option of helping to remove the noise as well from the images. And if you want a good image, you got to do dark frames. So I'll be doing this for the next few minutes, but I want to thank you guys for being part of this. SkyTour LiveStream wouldn't be the same, wouldn't exist without you. And I just think you guys are awesome to come out here and hang with us for a while. I hope you enjoyed the sights tonight, and I will talk to you on the next clear night, which could be tomorrow for all we know. I said that yesterday too, and here I am. SkyTour LiveStream is a production of the SkyTour LiveStream Observatory here, the John Zach Memorial Observatory in Connecticut, and soon the Hayne Robb Observatory in Arizona. That is the name of the new observatory. First time I mentioned it right here tonight. So you guys have a good evening. We will talk very soon. I will be back. Trust me. Only bad weather keeps me out of that dome. All right, you guys. Good night. Have a pleasant tomorrow. Oh, yeah. See, now I get my dark frames. Here we go. Now we gotta go. All right, guys. Have a good evening. And that's where we were earlier.